a very substantial, formidable agenda of the conference: underground gas storage, reliability and efficiency. It is an annual conference. I think last year the conference was a success. And this year we have 22 presentations, and then there is a waiting list. There are a couple of presentations on the waiting list. If, with time allowing, we will give a chance to some other speakers to have their say. But first, let's give a floor to Mr. Han for the welcome address, and he is the deputy head of the Department of Gazprom, and Ms. Kiushkina, she is the representative of the Ministry of Energy. Though, is that correct? Is that the correct title? But anyway, Sergey, Mr. Han, why this is an important topical issue? UGS. Good morning, colleagues. I'm happy to welcome you to the forum. We have a great number of these sessions that are being held at the same time. Yesterday, I was just wondering what shall I do after lunch, trying to attend 3 sessions, but unfortunately I happened to attend only one. That's a good choice for us, and we have an exhibition over here. It is very authoritative, and you can do the test drive of our vehicle with the gas-driven motor. You can take a flight in a helicopter, and there are a lot of attractions, and I would like to thank you for coming to our annual conference. It's a traditional conference. We are pressed for time. We have 22 presentations, as Nikita Yevgenievich, our moderator, has said, and we have still presentations on the waiting list, and I would like to wish you success and interesting presentations, interesting discussion, and I would like to thank the organizers, because there was a lot of groundwork taken. There are some 20,000 people taking part at the forum, and the days are very busy from early morning till late into the night. Thank you. And Ms. Kiushkina, will you please just introduce yourself? Good morning, colleagues. I would like to welcome you. I am from the Russian Energy Agency of the Ministry of Energy, and I'm the head of the energy security of the infrastructure of the fuel and energy sector. We know what energy security is. It is the safeguarding the energy sector from the threats and hazards in the energy sector. And we realize that there are more strict requirements for the energy security, and historically in Russia the energy security is reliability and stability of the energy security. And despite all the geopolitical developments, the Russian fuel and energy sector is stable, operating just fine. And we realize that the major contribution into the energy security is performed by the fuel and energy sector, thanks to the human resources that work in the energy sector. I would like to thank you all, and fruitful work to you. Thank you, Violetta. And so we are through with the welcome addresses, and we will start the plenary session now, and I would like to invite the other panelists. Mr. Sergei Han, then Mr. Li Jun, the representative of the Chinese pipeline company. Ms. Galina Yakina, she's deputy head of the Transportation and Underground Gas Storage Economy Center, head of the gas transport economy from the R&D Institute, and Mr. Leonti Eder from VNI Gas Institute. He's a professor and deputy CEO for the prospective development. And the first talk of the plenary session will be given by Violetta. So that's the clicker. Can I have my presentation, please? So I would like to thank the organizers once again. In 2022, Russia initiated the study on energy security in the BRICS countries within the platform of the energy studies, and the initiative was supported by all the 5 member states, and the report of 2022 was prepared in 2023. The South Africa, as a follow-up of the Russian initiative, announced the issue of energy security, one of the key priorities of the chairmanship of the South Africa, and they studied the approaches of the BRICS to provide energy security. So the comprehensive analysis is important today, taking into account the specificity of the economic structure of each country, understanding the priority and ensuring the sustainable development and development of the common solutions for attaining the goal of energy security. The Russian Energy Agency of the Ministry of Economic Development was the coordinator of the activity from Russia, and all the departments of the Ministry of Energy took part, and the major energy national companies, their logos are at this slide, and I would like to thank all the stakeholders of this study. And now I would like to say a few words about the notion of the energy security. There are different approaches undertaken to assess the national security, depending the level of hierarchy that we are assessing, and that depends on the involvement of the country into the global energy security. And we see there are common stances, common positions designed to protect the priorities and intentions in providing the national energy security, depending on the priorities of the country and attitude of the country towards the energy resources. Previously, there was a working group of Skolkovo, and we analyzed the energy security of the circumpolar world. The reason why this region, because the Arctic nations had some similarities. We saw that one of the trends is energy efficiency, self-reliance of energy resources, and accessibility of the energy resources at adequate prices with diversification of energy resources. So the tools of energy security are specific for each country, but it all gravitates around the energy resources. And now the advent and transformation of the hybrid threats that form risks to the energy security, and the energy sector changes pose a challenge to the energy security of all the world. And that's why it is necessary to be more flexible with respect to the process, and it is necessary to develop the possibilities of influence on those processes. And the conclusion, the best investment of the countries is a coordinated efforts of the countries to energy security, to exchange knowledge regarding the energy security, and adaptation of the economies to the effects from the impacts on the energy security that arise in the past years. Such kind of integration is very important, and it meets the challenges, despite BRIC countries are all different in as far as the sufficiency of the energy resources is, and the structure of the energy mix. The approaches should be coordinated. Back to the report. The Russian Federation is a strong power, energy independent. We have strategic potential of the primary energy resources and reserves of the energy resources. We have a diversified fuel and energy complex. Russia pursues equitable energy policy to combine all these sources of energy, fossil fuels, renewables, new energy sources, with the emphasis placed on state-of-the-art green technologies to provide a clean energy mix. The fuel and energy mix is structured and well balanced, and it is easy for us to respond the arising challenges. The development of the energy structure provides for supplying the different energy sectors and industry sectors in different geographical areas. It combines energy of the centralized power with the distributed power generation, and the energy resources could be replaced, and it is important to focus on the power generation.
The contribution of electrical power into energy safety and security, which is of paramount importance for the state and is achieved via legislative, normative, and other measures. And bottom line, these measures are adequate to identify the destabilizing factors and threats. Our documents for strategic planning in energy are streamlined and systemic. That way, we can structure explicit connection between basic principles of the character of public activity and the mechanisms of implementation of governmental policies in energy safety and security. In Russia, there is the model based on the balance of interests and the interconnections and fair risk allocation between all the stakeholders stakeholders and participants of energy chain that expedites safeguarding energy safety so that we can cap risks and crises. As to the priorities of energy policy, nowadays we have embedded the measures for more resilient and sustainable energy, which would be adequately rebuffing all the contemporary hybrid threats. Against the backdrop of the impact of technological sanctions, Russian Federation carried through with the transformation of scientific industrial policies. Nowadays, there is a redefinition from commodities to commodities innovative development, sustainable development, low levels of emissions of greenhouse gases, the change of the structural economy and its diversification in line with surmounting climatic challenges, mindful of the global changes around the world. The work is done on prolongation and streamlining of the strategic plans until 2050. That will be a new state of affairs for the energy of Russian Federation. Having said that, Russia traditionally ensued from the necessity of well-balanced development of fuel energy complex. On the one hand, it would expedite the sustainable and robust energy supply to consumers. On the other hand, it would mean low carbon emission development of economy. All the innovations of the country have been geared towards the development of economy. And also, this is about good coordination and steering all the earmarked public measures on scientific, technological, infrastructure, and HR supplies. As to innovative directions for our countries, there are high priorities related to the use of state-of-the-art disrupting science-intensive technologies and solutions for the entire technological chain. First and foremost, this is about the aggregated requirements for being sustainable, safe, and energy efficient. Energy safety and security of the country encounters different external challenges, and it's necessary to take on board important solutions to develop fuel energy complex of the country from within. Against the backdrop of great changes in energy markets, the Russian Federation has been putting together its experts and infrastructural policy, which also impacts internal sectoral tasks related to the development of Russian fuel energy complex. As I have mentioned before, our fuel and energy sector is very appealing for cooperation. We carry through with all our commitments to be fully discharged. The contribution of sectoral directions of fuel energy complex for energy safety of the country is identified by their capacity on the basis of effective use of internal and external resources to provide for sustainable, resilient, robust energy supply to all the economic operators and households without jeopardizing economic and ecological safety of the country. In the sectoral part of the studies, it was represented by different schools of thoughts and different tasks to be resolved by utilities companies to accomplish strategic goals to develop the sector for the sake of energy safety and security. The study shows the roles in each and every energy sector in providing for natural homeland security and safety of the country when it comes to the implementation of state earmarked energy policy. And here, mindful of the high priority of this upscale event, I would like to highlight in certain bullet points of the gas sector. It's common knowledge that natural gas is very important as a fuel for sustainable development, low on the emission, which is very important nowadays. And you, as the organizers and attendees of the forum, know everything about sustainable integrated work, underpinning all the sectors, all the spheres of activities in order to scale up the level of energy safety and to mitigate challenges and threats. Sectoral aspects of energy safety and security are also characterized by the degree of satisfaction and needs of fuel, energy resources, robustness of the system and its vitality, sustainability of the system. Prudent, diversified, well-balanced fuel energy policy alongside high technological developed system of reserving the resources enhances energy safety and security. In gas sector, as we're all aware of, this function is exercised by the underground gas storages. There is the regional energy safety system having different benchmarks. One of them is about the supplies which would be sufficient for this gas from underground storages. This is about robustness and vitality of territorial systems of energy, which is based on their structural regime and mode parameters. The study also embraces that, aside with other topics related to safety and security in energy, which identifies the level of energy safety and security so that they could cap potential threats and they would never come true. By wrapping up my presentation, I would like to refer to very important bullet points. They are very important for all of us. The assessment of energy safety and security is a potent tool for fostering well-devised energy policy, and the analysis of its quality at any level whatsoever identifies the avenues for us to pursue to strengthen this whole system. Russian Energy Agency for Ministry for Energy Resources is ready and willing to put together joint endeavor to do the experts' analytical assessment aside other things. This has been gearing towards providing for energy thriving and well-being of our country. Thank you. Thank you very much. I have got one comment, if you allow me. We are familiar with this study of BRICS Energy Studies platform, and first of all, I would like to extend my heartfelt thanks to you as the head of this division for very incisive comments you provided for and very insightful studies you have been doing. And you structured your work in a very good way when you outreach different utilities companies, and Gazprom also is part of this work, and also when it comes to underground gas storage, you provided a very clear view of that. I hope we'll have success along those lines. Sergey, floor is yours. Sergey Khan, PhD, professor, deputy head of the department, head of the division of Gazprom, prospects for the development of underground gas storage and its role in energy safety and security of the country. Colleagues, I've been meaning to show you a video trailer aside my presentation, which consists of bullet points. I'll see if I can find it. Colleagues, by autumn-winter period of 2023-2024, there are big amounts of gas in underground storages of Russian Federation. It amounts to 72 BCM. of gas is by 87 BCM of gas higher versus the previous season. The capacity of underground storages at the beginning of withdrawal is more than 57.7 million cubic meters of gas daily, which is much higher than the last year. As to the volume of the total reserves of gas and the daily capacity of underground storages, we accomplished unmatched maximum values for Gazprom and for Russia as well. It's record high. We have fulfilled all the 10 complexes of overhaul and workovers to be fully prepared for the fall and winter season on all the sites of Gazprom. So we are ready to withstand the peak loads of this winter. Thank you. My apologies for not showing it on the large screen. So it crossed my mind just now that when Alexei Miller was presenting the situation with Gazprom readiness for winter season to the President of Russian Federation, I decided to show these figures as well. Mr. Miller, when he was reporting to the president, most part of his presentation he dedicated to underground gas storages. So you see how important it is for Gazprom, so that this topic was underscored in a report to the President of Russian Federation by Mr. Miller. Colleagues, the development of underground gas storage in Russian Federation, in the Soviet Union and in Russian Federation have been of greatest importance. In the Soviet times, it was the decree of the Council of Ministers of the USSR, whereby they were discussing those important issues. It was that way during the Soviet Union times and in Russian Federation. Check out this graph. In 1991, after the disintegration of the Soviet Union in the Russian territory, there were maybe only half of the active line, slightly more than that, of these gas storages and daily capacity, but nonetheless, the Gazprom company, first it was in the status of ministry, then a concerned Russian joint stock company. Nonetheless, they emphasized the importance of the development of the system of underground gas storage, and quite rapidly, within one decade, we fully reinstated those volumes and even over-exceeded it. Currently, the underground gas storage of Russian Federation consists of 27 sites of storage, 72.4 BCM is operative reserves. We can withdraw it within one winter. Apart from that, there is a big number of long-term reserves we can withdraw in case of emergencies, if something evolves. For example, if in summer we need very big volumes of gas for use, or there could be some unplanned workovers. But nonetheless, we'll meet winter with normal reserve. A very important indicator is 858.8. That's million of cubic meters. That's the maximum daily capacity. And also I'll show you other figures later on in other slides. This is the map showing where those underground gas storages are located. Most of them are in European part of Russia, but mindful of the development of gas industry with implementation of Eastern Gas Program, there will be an upscaled consumption in Eastern Siberia and the Far East. So we've taken several license blocks where we have prospecting work, having in mind the future construction of underground gas storage. Here you can see Gazprom structure of construction. Some are in the rock salt, some in aquifers, some in oil and gas fields. Gazprom is a sustainable supplier to other countries as well. It has got gas underground storages in Belarus, Armenia, and Serbia. As to the ownership of Gazprom, there are also storages in the territories of other countries, European countries, but we do not store gas out there right now. Functions of underground storage, gas storage right now, it's supply of gas to consumers in any conditions, be it cold winter, warm winter, or normal winter. Export supplies of gas, gas supplies to users in emergency situations and accidents, and supply of heat to vital utilities and to schools and hospitals, optimal regimes of operation of gas, also for trunk pipelines and production wells. So I mentioned 44% as a very important figure in the previous slide. Red dotted line is gas consumption in Russian Federation. It's not a theoretical picture, it's first-hand experience. It's a fact. That's the way it is. If now we fully regard the fields for all the needs to be met, so we'll have to drill twofold of wells as well, and the average range of transit is 2,500 kilometers from production places to centers of production, sometimes to the south of Russian Federation. It will be 3,500 kilometers. That will mean more wells, more borehouses, more pipelines, more upstream. That would hike drastically the capex and opex. And as to green, we chose the places whereby we can inject the surplus of gas in summertime. On the right-hand side of the graph, you can see winter consumption when we can withdraw gas out of those underground gas storages. Navy blue line shows upstream production and all the work related to that for also upstream and downstream facilities and transportation. Notwithstanding the fact that since 1991 we have been trying to live amid market economy, fair competition, so on and so forth. But I should say that our market economy is inferior when it comes to gas, because in winter and in summer, gas has the same price. I would like to underscore this fact. Gazprom, by constructing underground gas storages, having plethora of those reserves and stockpiles, it's huge capital investments and capital expenditures, but we do not earn much to that because price is the same in winter and in summer for gas. We do a lot of work, but mostly this work has been gearing towards stabilization of the entire gas and transport system, entire system of gas upstream, to safeguard the robustness of the system.
And it refers to the consumers both in Russia and abroad. The light orange at the bottom is the consumption of gas. Of course, the consumption is lower in this summer because we do not use much, only to cook. But when we have a heating season, then the consumption peaks. I would like to draw your attention to what is happening in the other countries, and the other countries are dealing with storage energy, because it's not only about storing gas, but storing energy. It's a beautiful picture, but it shows that if there is a need to store for a long time, then there is no alternative to methane, and they're quite high on the agenda in Europe are renewables. But I would like to state that power generation, solar, using solar or winds or tidal waves is quite good. It's very useful. But there is a certain controversy. When we need energy, there might be no wind still, or cloudy, and in winter we have clouds, so the solar panels won't be working, and so the energy in the storage batteries is not stable. So that's why gas is reliable, and if there are UGS, all the fluctuation of both production and the consumptions could be offset, and because the consumption depends on the cycle of the livelihood of human beings, and if there is a production which is not stable, and there was a crisis of 2022 when the prices for gas peaked as a result of wind still in the Northern Sea, and then those wind turbines did not produce electricity. So what could be the way out? It is using gas turbines, and gas turbines use methane. And who can supply gas, or what can supply gas? I think it is the UGS, because no accumulators or no liquid pumps can do that. At least they are inferior to the UGS. So UGS can guarantee a reliable supply, and the UGS will play an important role to ensure reliability of the energy mix. Those that use both conventional energy sources and renewables. So I would like to draw your attention to the global UGS system. It is well developed. There are 10 UGS in the world with the total capacity of 450 BCM, and the total storage is 7.8 million cubic meters per day. They are located in 3 regions: in Northern America 65%, in Europe 21%, and at the territory of the former Soviet Union 7%, and 5% in Asia, 1% in South America and Africa. So describing the UGS system in the world, we should take into consideration the opinion of the European experts. In 2014, they used to say that the UGS in Europe are facing big challenges. Mr. Andreas Berner has been working in the UN gas storage, said trying to set up comfortable conditions to the consumers in Europe. There were steps to liberalize gas market and set up the consumer-oriented system. The vertically integrated companies were broken, and there is no coordination center that resulted in the egoistic behavior of the new companies. There are new products, services, and clients, and the issues of reliability and energy safety, energy security are disregarded. So that resulted in new problems for both suppliers and consumers, and it means the problem problems for the development of the gas systems. The lack of investments and prospects for developments create unfavorable conditions for providing energy security. Examples is the degradation of the UGS in Great Britain. And one of the UGS, which accounts for 60% of all the storage capacities, was closed as a result of lack of financings for overhaul of the UGS. So it's not for the first time when the market is trying to regulate the large infrastructural projects. We can recall the blackouts in Chicago, or we can recall the issues of water supplies in the 90s when the water company of Great Britain was privatized and the participants, small companies, started competing, and the companies that bought out the infrastructure. And so to get a profit, they stopped spending money on repair, and the summer was hot, and so the water supply was disrupted. So customer orientation and trying to compete for the services of the UGS could result in lack of money for the overhaul of the infrastructure. No entity will be thinking about investments, because if the price for the services fluctuates, and if it is necessary to reduce the capex, to reduce the tariffs for the services to ensure profits, then what entity, what company will be investing? No capex the capex will be zero. The former managing director of French gas storage, France Giraud, said that the increase of spread of the prices is based on one function, that is regulated the seasonal demand, but it is the tip of the iceberg. The major important function of gas is underestimated, and these functions are ensuring energy security and optimization of capital costs. In 2022, the Brussels felt that something is wrong with the centralized gas markets. Urgent steps were taken at the legislative level. Two laws were changed of the EU and the European Council. It is regulations on the measures of ensuring the gas supplies and access to the networks of the natural gas transportation. These measures were designed to ensure the reliability of the supplies. The first requirement for the operators was to fill the UGS not lower than 90%. Another is certifying the UGS operating to eliminate the risks of supply. And third, it is providing discounts to the consumers to provide incentives for the use of the UGS. And the regulators have been empowered to repossess the UGS and with the respective payment, and the principal use or lose regarding the UGS. And many clients just reserve the capacity for dozens of years to ensure the supplies to their customers, and the requirements to pump gas, irrespective of the price and market turbulences, result in the termination of the long-term contracts, which is the foundation of the reliability. And then some companies they reserve the UGS for the prices of 2019, and that does not cover the operational prices. But what could be done if there is a shortage of some commodities and services? And the answer is obvious. It is necessary to stimulate the suppliers of those goods and services and to reduce the consumption of the goods and services. But the European commissars had a different answer. It is to force the operators to provide their services free of charge and provide discounts to the consumers. Such decisions result in the closure and elimination of the UGS as commercially inefficient, and it causes the degradation of the system of the energy security. So the situation in the US is absolutely different. Full UGS is the foundation of the gas industry. They have the transportation network, and if the winters are harsh, then the UGS are used quite vigorously. Altogether, there are some 400 UGS used in the US. Power generation using gas is increased at the same period when there is a peak load for the heating system at winter. So when the cold winter days come, the UGS then provide the gas, and they cover the 22% of the requirement of the gas. Despite the liberalization of the market, one of the function is integration into the transportation systems, and the storages work as an integral part of the federal system and different states. Only some part of the gas is sold through commercial structures. Independent companies that provide services are also owners of a share of the UGS. The market is organized in such a way so as to meet the interests of all the stakeholders, both from producers to small consumers. All the UGS are subdivided into three groups. 1/3 is owned by the local distributing gas companies. 1/3 is owned by the gas transportation system, and the rest is owned by the independent operators. Such a structure make it possible to provide effective services of the UGS to those who need those services. Next slide. Getting back to the Russian system of the UGS, I would like to emphasize that Gazprom has competencies to both create and operate the UGS of all types. At this, the unit costs are quite competitive. And I would like to note that we in Gazprom did accumulate the experience of operating UGS. We now create the UGS in the salt caverns, which could be used for strategic supplies of oil and petroleum products. So the conclusions: we do have experience, we are a highly responsible company, and we are ready to bear the brunt of the responsibility for gas supply, and we are always open for cooperation. Thank you. Thank you, Sergey. And I think you have set the pace, set the bar for the conference, and I think you have ideologically and conceptually set up the pace, and I think we will be moving along the lines that you have suggested. Next, I would like to give floor to our next speaker. The floor is given to our guest, Mr. Lee Jianjun, who is the UGS Group Director of China National Pipeline Corporation. And the topic of the report is current practice and research directions for underground gas storage of Pipe China. The floor is yours. Good morning, ladies and gentlemen. My name is Lee Jianjin.
У него вроде микрофон выключен, что ли?
Ребята, он по-английски говорит.
Так где микрофон-то у него не включен, мы ничего не слышим.
Звука. Нету звука.
Низко кабине нет звука.
У нас нет звука.
Я понял, что. До этого приходил сигнал, да? Когда говорили?
В Китае созданы условия для того, чтобы создавать инфраструктуру. Это гарантирует эффективные поставки газа и также реагирование в условиях чрезвычайных ситуациях. Если вы хотите организовывать бизнес в Китае, то Pipe China может быть вашим.
old caverns into underground gas storage, and swiftly establishing a working gas volume of 50 million cubic meters. These 5 old caverns have been operated in good conditions for 7 years. By utilizing a substantial number of existing old salt mine caverns, PipeChina has significantly expanded the construction process and reduced cost. In accordance to the statistical data, there are about 20 million cubic meters of old caverns created by the Brown Company in China. So if we can only convert a small part of the caverns, we can achieve the big storage capacity. The following picture shows the process of old cavern evaluation and conversion. There are 7 steps. First is data study, the geological and well logging, drilling, and brine production data are connected and analyzed, and the caverns are selected. The cavern passes the second step, we'll put into the third step. We'll do the sonar survey to see the detailed shape and the volume of the cavern. Then the stability evaluation should be conducted to see if the cavern could be operated for long-term pressure changing conditions. After that, the ceiling assessment should be conducted to see the cap rock and the pillar between the adjacent caverns to see the ceiling, are there any ceiling issues. Then the old weirs should be repaired, usually will be mined or plugged. New weirs will be drilled and run into the new casing designed for the gas operation. After all this, the last step of MIT test should be conducted to see the weir and the cavern and the head and everything is okay for gas operation. After that, the cavern is put into deep running. The third sub-technology developed by us called cavern design and monitoring evaluation technology. We have developed an indoor simulation software named CavSimu, which is used to help design the leaching process and the analysis of the leaching, and especially after the leaching process, this software can be used to simulate the injection and the production, mostly to calculate the cavern pressure and temperature inside the cavern. The middle picture shows a comparison between the sonar and the simulated shape of CavSimu. We can see that the shape matched each other very well, and especially for the bottom shape. CavSimu can simulate a very accurate bottom shape with the sonar, and this can help us to put inside the leaching pipe positions during the leaching process. Then we know that strict monitoring of the process is necessary in cavern construction. Those key parameters, including cavern shape, volume, blanket level, pressure and flow rate, brine concentration, should be monitored carefully. In order to fulfill this task, we developed a software tool called GSDMS And this software can track the cavern construction process, scheduling sonar survey, and simulate or calculate the brine concentration, calculate the pressure, the wellhead pressure, including the injection and production pressure, and any prediction of the underground leaching issues. And we developed a very important instrument which is used to detect the blanket level. So my friends here, if you are working for the underground salt cavern gas storage, I think you are familiar with the blanket level. This is a very important parameter. This instrument is based on the fiber optical technology, and with detect accuracy up to half a meter. This is the fourth sub-technology I want to introduce, called solution mining under gas, SMAG for short, and associated technologies. Jingtan gas storage, as I've just told, has successfully practiced experimental project of solution mining under gas and nitrogen, and developed a comprehensive set of technologies. Let's see the left group of pictures. These pictures shows a process that we conducted to repair the shape of a cavern. We can see there's a ledge in the cavern. When we do the debrining, the ledge fall and damage the debrining pipe, and the natural gas is leaking. So we extract all the natural gas, but the ledge is still there. If we want to eliminate the risk, we must leach or eliminate the ledge. So on these conditions, we can only use SMART technology. Use the natural gas as the blanket, inject the gas and debrining, and inject the brine and take the gas. And we tried this for several months. See the third pictures. After the smuggle process, we'll see that the ledges has been leached, and the debrining risks has been eliminated. So we put into the debrining pipe again, and successfully in debrining process. During this process, we achieved by increase the volume of the cavern by 14,000 cubic meters, and resulting in an economic benefit of nearly 8 billion yuan. The right picture group shows the nitrogen blanket leaching technologies. This is especially required by the brine company, because we asked them to help us to process the brine. So they asked us to. We knew that before we use the diesel as the blanket, and it will pollute the brine. So the company asked us to use the nitrogen. So we developed this technology, and we conduct a pilot test. The last picture shows the sonar shape after several months of leaching on the nitrogen. Leaching on nitrogen can reduce the construction cost, because the nitrogen equipment could be used for more than 3 wells at the same time. Then, for the key technologies for the construction of complex folded gas reservoir gas storage, this technology group is especially developed for one of our gas reservoir gas storage called 123, which is belonging to PipeChina. strengthening the 3D detailed geological modeling and the numerical simulation research, deepening our understanding of gas reservoir, provides the fundamental basis for optimizing the gas operation and achieving storage capacity and the production targets. Besides on the existing geology and production data, we utilize the new drilling data, rocky core analysis, laboratory testing, and especially the routine monitoring results. The application of phase modeling technology is used as well to establish a 3D model and a numerical model. It helps us to finally characterize and describe the reservoir trap, the reservoir property, the sand bodies characteristics, connectivities, and bottom water distribution. We use the popular softwares called Petra and Eclipse to finish this process. Here is the drilling and casing cementing optimizing technology. This is yes, it is especially for the same 123 gas storage. During the research, we achieved 5 sub-technologies. The first is a micro-bubble drilling mud system and a self-clearing gel plugging agent. We developed this agent. This agent is especially used for the workover to balance the pressure. The second is material selection and design methods for casing pipe. This is especially developed because of there's a 6 salt layer above our reservoir. And the creep effect of the salt is very high and exert extra strength on the casing. So we must pay more attention to the selection of the casing and the thickness of the casing wall to anti the creeper stress. The third technology is cement study system process and processes. A steer for the 123 gas storage because of the salt layer. When you all know that it is difficult to cement the salt formations. So we developed a special cement study for this. And the software are used to position the centralization to get a better cement quality. And the last is the efficiency pre-flush fluid for well cleaning and high volume displacement methods are employed as well. Now, I will talk about the reutilization of old wells and well sealing technology. Reutilization of old wells are especially used for the gas reservoir, gas storage. This can be used to increase the construction speed and cut the cost. The left figure shows the old well treatment process. For the reutilized wells, the casing integrity, cementation, and the casing head status should be reassessed. And for the abandoned wells, usually step process should be taken. First, squeeze in the perforated gas and oil zones. After that, the leaking casing annulus should be plugged, and then plug the internal well bore. Now, for the key technologies for the integrity management gas storage, I will talk about the cavern well surface safety monitoring system. A series of technical exploration and on-site application of the integrity management of salt cavern, especially salt cavern underground gas storage, are deployed. This effort has essentially established a safe monitoring system for UGS facilities. Many include 3 parts. First is the surface. We monitor the temperature, pressure, and flow rate. as a basis for the inventory calculation and the underground issue prediction. And then the ground subsidence monitoring. And we know that the creep effect of the salt will induce the shrinkage of the cavern volume and result in the ground subsidence at last. So we must monitoring the ground subsidence carefully to avoid a disaster. Then the micro leak monitoring and the UAV monitoring, especially for the third part construction, to avoid the damage to our facilities. For the wellbore, we will carry out the fiber optic leak detection to see if there are any leakage in the annulus or in the gas operation pipe or the casing pipe. And for well casing corrosion monitoring, we use logging. I use caliper logging or electromagnetic logging technology. And the wellbore deformation monitoring, I use logging, caliper logging. For the cavern, sonar survey should be conducted every 4 or 5 years when it is put into commission. And after that, we will restart the stability evaluation to see it is in good conditions or not. Then the microseismic monitoring has been installed, and to see the gas operation program is good or not. And of course, the monitoring wheels are still there to monitor the copper rock and some big fault to see are there any leakage. Then I will introduce the digitalized salt cavern gas storage collaboration platform. We developed this platform named Cavern. It includes several modules, such as a data center, helps to collect the logging data, production data, drilling data, everything. And then geological modeling help us to understanding the geological structure. And then the cavern simulation. We integrated this cavern simulation function in this cavern. Then the stability assessment, debrining management to calculate the debrining pressure and the brine volume, all those key parameters. Then the economical evaluation to see if this cavern is designed under best conditions or not. Cavern has enhanced the comprehensive life cycle management of salt cavern UGS. So in accordance with the development plan for gas storage facilities, to strongly support the constructions, effectively control gas operation risks, and ensuring high quality development of the business, PipeChina will face the following challenges in the future. There are four challenges. First is rapidly growing natural gas peak shaving demand. Second is the poor geological conditions for salt and aquifer UGS. And third is the cavern resource competition increased with other type of underground storage. For example, the CIS, compressed air energy safe storage. The last is the risk of construction and operation increase with the continuous development of the UGS. To overcome these challenges, we will start to form new research directions in the future. First is break through the construction constraints and accelerate the UGS capacity development. This is very important for PipeChina. The left picture shows the cavern created in a very thin salt layer. For this kind of salt layer, we cannot use the common technology, the vertical cavern technology, because we can only get a very small volume But if we develop this horizontal multi-step cavern creation technology, we can create a horizontal cavern and achieve the volume target, resulting in the storage capacity target. The right picture shows the cavern in China. Most of the salt formations in China with high insoluble content. And after the leaching, this insoluble will cover the bottom. Usually, it will exceed 40% of the total excavated volume. We studied this volume, this insoluble content, and see that there's some void inside the content, nearly 30%. So if we can use this void to store gas, we will increase the working gas volume for the cavern. Now we have already carried out a pilot test in a place called Yunning in China. Now, the left picture shows caverns created in the very deep salt formations. The very depth of the salt exceeds 2,000 meters. We know that the deeper the creep, the higher the creep is. So this high creep effect will exert the extra stress on the casing and increase the shrinkage rate of the cavern volume. But the salt here is very pure. But if we want to use this salt to create caverns, we must solve these problems. The right picture shows the complex cavern created by the Brown Company in China. There are a lot of caverns created by the Brown Company. These caverns are always created by two connected wells or even more wells. The shape is not conformed to the gas cavern, the design standards for the gas cavern. So if we use the common gas cavern standards, we cannot convert these caverns into gas storage. But there is a large amount of these kind of caverns in China. So if we can develop new standards for the conversion of these kind of caverns, we will achieve the construction speed and reduce the construction cost for the salt cavern gas storage. But it is really challenging. This is the aquifer gas storage. Because of China's lack of the resources to create underground gas storage, so we want to develop a new type of aquifer type gas storage in China. I know this aquifer gas storage is popular in Russia, and I visited one near here. But we have none experience in China, so we will import or learn from our Russian friends, including all the technology below. For example, the geological assessment, research on injection processing seepage patterns and the dynamic storage capacity loss, design optimization technologies, drilling and production engineering technicals, service engineering technicals, and safety operation controlling and monitoring technologies. All of this we must learn from Russia or some other experts. The second is enhance the research and the development of core equipment to meet construction and operation requirements. First, we will try to develop a sonar tool all by ourselves, because before we used a sonar tool from a German company called Sokon, but it is difficult for us to carry out the maintenance because they are far away. So we decided to develop this tool all by ourselves. And then is the large-sized downhole tools. We have two salt cavern projects in China. We use the large-sized casing, which is 13 and 8 inch. But because of the downhole tool size, we can only use the subsurface safety valve and packer for 7-inch gas operation pipe. But if these will limit the gas extraction rate. So we want to develop the large size downhole tools. For example, the packer, which is matched with the 9.58 gas operation pipe. If we successfully develop this technology, we can increase the extraction or the production flow rate a lot. The third research direction is optimization for the gas operation of the UGS in service. The target is to increase the working gas capacity. This is the faster way to achieve the working gas target. These is our special technologies for our special underground gas storage. So I won't introduce one by one. The last one I will make an introduction. That is the use of the pressure energy for the gas storage to save energy. We know that the wellhead pressure, there's a big difference between the wellhead pressure and the main pipelines. For example, our Jingtan gas storage, the wellhead pressure, the maximum wellhead pressure is about 17 megapascal. For the pipe, it is only around 6 or 6.5 megapascal. So there's a big difference. But this pressure energy we lost in before. If we can collect this pressure energy and convert it to electricity, there will be economical benefit. So the kind of high pressure expansion turbine and or multi-stage expansion turbine and its associated controlling system should be developed in order to achieve this. The last research direction is enhance the gas storage facilities, technical systems, and expanded the comprehensive utilization of our gas storage facilities. That is because PipeChina wants to expand its business. There are three research directions. First is CIS. Now this is very hot in China. There's a demonstration project near our Jingtan gas storage, and it is already put into commission with efficiency is about 60%. But the pricing system have not created already, so make money now is very difficult. But in the future, if this CIS developed together with the solar energy or the wind energy, and it will benefit a lot, which has been studied by some experts. The second is the hydrogen storage. I know there are a lot of topics in this forum about the hydrogen technology. It is deemed to be the promising energy source in the future. And because PipeChina owns a lot of caverns, and these caverns is under very good conditions, we want to engage in this area and contribute a little bit to the technology. And last is the geological carbon dioxide sequestration in underground saline aquifer. PipeChina, I've just talked about that. PipeChina wants to create a underground aquifer gas storage. So we start to select several saline formations. So the best of the selected saline formations we can use to create an aquifer gas storage. The others, I think we can use to sequestrate the carbon dioxide. So PipeChina is a state-owned Chinese new company, but energy company as well. We want to work together with our friends and create a better future life. That's all I want to present today. Thank you.
Thank you very much, Mr. Lee Jianjun. There are several questions. I think that here we can see very good correlation between the previous presentations, presentation by Ms. Kushkin and by the presentation by the Chinese expert. So we can do a lot within the frameworks of BRICS, and we are very thankful to you for very interesting presentation. Sergey, I would like to comment on the last slides, several very last slides, whereby you've shown new directions for studies. It's helium, it's hydrogen, and also CCS technologies. What would I like to say about hydrogen in the caverns? I don't think it's possible to store big amounts of hydrogen in caverns because calorific value of it is 3 times less than in titanium. So we have to store big amounts of it, but it should be stored in porous structures then. So the second session of ours today will be dedicated to the problems and issues of storage of hydrogen in porous structures. That is my comment. Second comment is about CO2. Geological, the technologies of CCS, carbon capture and storage, is a very good technology. In our conference, in the second part of the sessions, there will be presentations about carbon capture and storage, among other things. So it's very gratifying for me to underscore the fact that our Chinese colleagues have been working with those groundbreaking technologies, and now second half of the day will similarly be dedicated to those important issues, and our specialists will share their own developments along those lines. So please don't go away. Please hold on here with us. Thank you. Thank you, Sergey. Well, maybe it's quite commonplace thing I'm going to say, but when specialists are real specialists and they are working on similar problems, then the solutions are in great similarity by the same token. So because it's about the same issues, about the same tasks, and people from different countries and regions are discussing the same thing. That's the way it is. I would like to invite for the next presentation Galina Yakina, Deputy Head of the Center for Economics and Transport of Underground Center of Gas, the role of underground gas storage in managing irregularity in gas consumption and supply. Colleagues, I would like to tell you about the role of UGS in removing irregularity in gas consumption and Russian Federation. The factors identifying peak consumption and irregularities for this demand could be split into 2 groups. It's climatic factors like temperature, ambient temperature, the length of fall and winter period, and the temperature of the coldest 5 days, and specificity of territorial sector or structure of gas consumption is the share of those sectors and the industries which is identified by the gas consumption at electrical power station, power plants, and household consumption. The territory of Russian Federation is in the Arctic and subarctic belt, moderate geographic belt. Continental climate is represented there, moderate continental climate and extreme continental climate, and muson climate and maritime climate, and a small zone southwest of Russia is subtropics belt. As you see on the right-hand side of this table, most of those climatic zones correspond to negative average yearly temperatures of the ambient air. According to climatology regulations, heating season starts at the time when the average daily temperature goes down to +8 degrees by centigrade. Here you can see the zones with different lengths of such days whereby the temperature is below +8 degrees by centigrade. So the length of, you can see the length of heating seasons. In most parts of Russia, heating season is more than 200 days per annum. On the right-hand side, you can see the table showing big Russian cities, the length of heating season, average temperature across the heating season, and the indicators of the coldest 5 days. We can say that oftentimes the difference between the coldest 5 days and the average temperature in the heating system is more than 20 degrees, give or take. In the right upper portion, you can see the average temperatures over January. Navy blue shows the temperatures of January in the range between -10 to -18. The darker color identifies the zones whereby the average January temperature is between -20 to -40 and below. Green color shows the zones whereby the average January temperature is above +8 degrees by centigrade. You can see the shift of those zones at the periods of extreme cold. Like, for example, in Moscow, temperature could drop to down to -30 degrees by centigrade. On the left-hand side graph, you can see some of the federal regions whereby the average January temperatures and the coldest days are indicated. And here you can see the dependence of gas withdrawal by consumers in fluctuations of the temperature, which is identified by green graphs here. And correspondingly, the response of UGS to the change in consumers' demand. All those spikes and inflections are synchronized, all those ups and downs in the graphs. Apart from climatic factors impacting irregularity of gas consumption, structural factors come into play, like population density, the level of gasification of the area, and the structure of gas consumption. In the upper left graph, you can see that the density of population of Russia is the highest in European portion of Russia. This part is mostly gasified as well. The analysis of gas consumption in different federal constituencies is indicative of the fact that in central region and the northern Caucasus federal entity, for example, the share of consumption of by industrial enterprises is about 30%. All the rest is the consumption by different sectors of electrical power capacity, utilities, housing sector, and households. Those sectors create this irregularity in consumption, which is shown in the below graph. Light navy, light blue cover graph shows the changes in and fluctuations in gas consumption. versus the industrial consumption, household versus industrial. As to monthly volumes of consumption, this irregularity can amount up to 20 or 30 MCM. The structure of consumption for way out into the future is not going to change drastically. That is, it will carry through for way out into the future, as far back, as far out as 2030. In case of absence of such an instrument of regulation, management of irregularities, so it will entail adverse impact. It will be non-optimal loading of production and gas transport capacities, and the growth of operational costs, the delay in response to peak upswing of gas consumption due to the remoteness of the places of production of gas to the regions of consumption, deviations from normative indicators of the activity of the operations of underground storages under intensive gas withdrawal by the consumers, or emergence of gas, excess gas. This flow chart, as you've seen it in the presentation by Sir Gates, indicative of the fact that thanks to UGS withdrawal in summer and injection in summer, we optimize the work of gas production complex and transportation complex. You can see the production which is smoothening around the month. And I would like to underscore the fact that the role of UGS for the operations of the entire complex is very important.
So the extraction of gas from the underground storage accounts for the major part of gas for the consumers, and it might be even more than 30% of gas that is supplied to the households, to the industries and other consumers. That's it. Thank you. Larissa, can we have the very last slide? So we have both export over here, and yes, these are all the sources. These are actually the sources that are used to supply gas to the consumers, including export. Okay, and if it is only the domestic consumption, do you mean then the share of the UGS is higher? It is, because 14%, it doesn't look like that. This is the average indicator, but when the winters are cold and when there is more extraction from the UGS, then this figure could be higher. We had a concept until recently that UGS work for the Russian Federation, and we cover the fluctuation of the export through the UGS in Germany, Netherlands, Serbia, and Czechia. Yes, that's correct. That's why I was mentioned that the UGS supplies the Russian households. Yes, and even the figure 32 is low, because the blue, the dark blue over here is export, isn't it? Correct. Okay.
Спасибо, Галина Александровна.
Thank you, Galina.
Я думаю, что тоже важный момент, и мы здесь видим именно
I think it's an
работу
important
очень
thing
важную НИИ газэкономики.
that we see the important work that the NI Gas Economica Institute is doing, and we are cooperating with the department, and
я думаю, сейчас вот как раз
we are cooperating with the department 312 of Gazprom. So I think we should
восточного вектора
make the cooperation even more vigorous, taking into consideration the gas flowing east, and we should make the calculation and study which regions the new projects for the UGS should be placed. And referring to the issues of gasification and then supplying gas to the new consumers will affect the capacity of the UGS. Do you think more UGS should be needed, not only in the new regions like in the Far East and Siberia, but in the European part as well? Because I think the UGS are not spread evenly geographically. And if the lower temperature results in 30 millions per day, then when the gasifications of new households will take place, then I think that particular volume will have to be increased. Okay, and if it is utility sector, then the unevenness is even accounts for 80%. If we increase the gasification by 20 BCM, then it means 10 BCM capacity will be needed. Yes, but with the climate change, we can see that we have a higher fluctuation of the temperatures between the warm and cold winters. And then more gas supplied to the utility sector and households will mean that more gas should be withdrawn from the storages per day. Talking about the behavior of the consumers, if it is cold, do we supply more gas? And if it is warm, do we reduce? Yes, the households are trying to save, and then they tend to reduce the consumption, reducing the flow of the gas. But if it is district heating and there is no control of the gas consumption, then it is unlikely that we will have a drastic reduction of the gas consumption in warm seasons. So despite the drastic fluctuation of the temperatures, the consumption will be higher, and it will not depend on the temperature. The more so that the fluctuation of the temperatures within a month might be very frequent. Okay, thank you. So the general idea that we will still have to increase the UGS capacity. Correct. One comment, if you please, what you have said, Sergey, in your presentation, that the US have 400 UGS, but mostly these UGS are small capacity. They are small, and because the priority was given to supply it to the small-scale consumers, and I think we should capitalize on the experience of the country that has many UGS, and we should have UGS, small UGS, but covering large geography. Okay, talking about developing the capacity for the UGS, I would like to give floor to Dr. and Professor Mr. Leonti Eder, and he is the Deputy CEO for Prospective Development of Gazprom gas modeling specifics for UGS facilities. Good afternoon, ladies and gentlemen. Mr. Sergey Han started the conference with showing a video, and then an idea occurred to me to start mine with the video as well, and it is in correspondence with the ideas I will be giving. UGS is an integral part of the gas supply system of Russia. The UGS is the most efficient and safe way of regulated uneven consumption. The peaks are shaved and the flexibility of the supplies ensures. Gazprom structure is composed of 23 UGS. It has the UGS in caverns, and then in the depleted reservoirs and in aquifers. There are 2 UGS in caverns. There are 5 federal districts that have UGS to make the supply reliable. There are new management methods are used to do the model. There are technical constraints that are applied to the rocks that the UGS is. The tasks of the UGS could be divided into strategic and tactical group. The strategic group is having the optimum parameters, and when choosing the management strategy, it is necessary to take into account the constraints related to the technologies of operations. So the calculus is done using the digital models, digital twins, and the model is integrated with the reservoir models to take into account all the constraints that are imposed by pumping the gas and extracting the gas from the UGS. The tasks of management have strict demands for the time, deadlines. The response time is short. It is necessary to have a decision-making support system, and the UGS is complexing the models with the neural net and developing digital twins. Managing the operation is based on the comprehensive integrated models developed by VNI Gas, and it is capable of improving the quality of the decision taking into account the uncertainty of the external factors.
Спасибо. И я попрошу загрузить, соответственно, презентацию. Презентация как раз будет посвящена вопросам, связанных с цифровизацией, поскольку это сейчас основной тренд развития разных направлений, что, собственно говоря, внесет в себе основные элементы именно принятия наиболее обоснованных решений. И я 2 слова буквально расскажу о той работе, которую ведется в «Газпром». Основным научно-технологическим центром, соответственно, ПАО «Газпром»,
VNI Gas is the main technological center that develops the methods applied at the UGS. At present, the integrated modeling is the main tool of addressing the issues of both operation of the UGS and with reference to the strategic tasks. And so we have identified a number of the tasks that are included into the integrated modeling approach, and in my presentation I will talk about these tasks one after another. So, the development of the models is related to digitalization, creation of the digital basis, and another is solving operational tasks. As you know, all the operation is supported by science, and integral part is developing the operational curves, and integration of models is the most accurate tool. Another thing is related to the UGS system development strategy, and we are talking about the creation of the UGS and developing the parameters of the operation of GS. Another thing is sustainable development related to the storage of the CO2 and also injection of the non-hydrocarbon gases. So non-hydrocarbon gases is not only CO2 but helium or nitrogen used as a buffer of storage of the natural gas. So integration is an integral part of addressing these tasks. Slide 3 shows that time-wise this process of modeling and developing of the technical indicators was going through a number of the stages. First, developing the methods, then we developed the balance and network models, and first hydrodynamic models. Then there was a period when the systematic work on modeling was not that robust, and if we compare the operation of the professionals that are dealing with the UGS, our colleagues that have been developing the models for productions became leaders, and we will have to catch up with them and to compensate the time lost in the noughties and early 10th. But we have a task to finish to complete all the integrated models till 2025. I'm talking about the models that are used in operation of Gazprom, and the next step will be developing neural network models, and we use Kasimov field for our pilot work, and neural network modeling is designed to develop the regime curves and other indicators using machine learning, and those tasks could be solved quite fast and efficiently. Another work is developing digital twins, and it is quite high on the agenda, and everyone is talking about digital twins and the tasks it is capable to do. So we will be developing the digital twins of the UGS, describing the status of individuals' storages, and it is one of our priorities. So, talking about those tasks, the slide 4 shows that the integrated models at present include the following work. It is modeling the reservoirs, wells, gathering systems, and integrated models that encompass all the chains from bore till the entrance to the big trap area of the pipeline. So Russian software is used, and all the models will be of the UGS will be translated into Russian software, and we are trying to expedite the process. Next slide. VNI Gas has an experience of developing the software using using machine learning methods. Shown over here is the projects. It is a joint project with our colleagues from Germany, and we developed a neural network model, and salt rock cavern was used, and so it was necessary to regulate the surface equipment as far as neural network was concerned. So we have developed the models for the compressors and also for the injections, and based on such a successful and positive experience, capitalizing on it, we have set a task to translate the integrated models using machine learning. So the issue is that it is necessary to calculate a great number of the realization of the model and to teach the software to take the most efficient decision based on the changing of the parameters. Another task that is addressed through integrated modeling, it is calculating the life of the service life of the UGS. And you can see that it is necessary to do the adaptation of the hydrodynamic models as far as the cycle of injection and withdrawal is concerned. And so the cyclicity of the operation of the UEG is different from what our colleagues are doing, those that are modeling the production. And the diagram is showing the major milestones that our model will have to be adapted to calculate the regime curves for injection and withdrawal, taking into consideration the peak capacity, the peak productivity, because it is the most important parameter. Another activity related to the development of the integrated model. This is justification of the optimum regimes and indicators of the greenfield UGS. The picture shows one of the UGS that is being constructed in the Republic of Udmurtia, and we have developed the hydrodynamic model, which has the parameters of the withdrawal for this particular facility, and it is necessary to switch over from 3D model to have the forecasts for different modes, and the deliverables should be included into the design and engineering package. Another thing is international cooperation.
Обмен опытом, в том числе с китайскими коллегами в области моделирования.
Сегодня китайские
коллеги отметили, что как раз опыт эксплуатации объектов подземного хранения в водоносных горизонтах стоит как одна из таких приоритетных задач, поскольку китайские коллеги в том числе движутся в этом направлении. И вот здесь вы видите, мы, соответственно, не так давно построили интегрированную модель одного из хранилищ, соответственно, расположенных в Китае. Кроме того, активно интересуются этими вопросами коллеги из Казахстана и других стран. И вот этот опыт создания подземных хранилищ в разных пластах, пористых, соответственно, водоносных, позволяет активно развивать сотрудничество как в фундамент для
able to use cooperation as a foundation for the strengthening of the external economic relations. Another aspect is sustainable development. Sustainable development is a buzzword related to decarbonization, and we have our colleagues from VNI-Gaz present over here, and they started to develop the compositional models for methane ejection, CO2 and nitrogen injection, using those gases as a buffer gas to choose the optimum mode. Slide 10, it's something special. It is related to CO2 injection calculations.
Этим вопросом мы тоже занимаемся, поскольку
опять же идет активное воздействие и на пласт, и на породу. Здесь нужно понимать основные процессы, связанные с динамикой движения композиционных составов неуглеводородных газов. Это очень интересная проблематика.
It's a very interesting issue altogether. The decarbonization is slightly less high on agenda, but when it comes to helium, nitrogen, and other non-carbon gases are very high on the agenda as most topical nowadays. On conclusions, I would like to underscore the fact that integrated simulation is, and then machine learning neural networks are very important for very precise assessment and computation of different curves, of different regimes, different indicators. And so we have been shifting towards digitalization. It's important for strategic goals of streamlining the system of UGS, international cooperation, and sustainable development are very important issues for us. Thank you.
Ну что, есть еще у нас время.
We have some time left.
Как минимум 2 китайские компании сейчас в зале.
And there are 2 Chinese companies present here.
Мы открыты к сотрудничеству.
And I might say that we are open for cooperation.
Вот, скажем,
Our research institute is open for cooperation. We are ready and willing to work with you. Thank you.
Какие у вас предложения, Никита Кириллович?
Я думаю, что
What shall we do next?
поэтому можно закрыть нашу
We are slightly ahead of the
пленарный блок.
agenda, so there will be next presentation to wrap up the plenary block. And green energy and decarbonization is very important, so I'm very thankful to the speaker.
Противник не зеленой энергетики,
And
а вот ее глобальный
I'm
форум,
thinking
когда говорят, что
about
она
green
заменит
energy,
всё.
but it's not true that green energy will replace everything. It will substitute gas as well. I don't believe that, and my presentation in the next session will be exactly about it.
Интересы к этим вопросам.
So now we can see the scaling up in coal production. Gas is
востребованный источник энергии, за него
very high on the demand source of energy. There is struggle over gas. And to my way of thinking, in future, when there will be the reduction of gas production in the USA, because 13 trillion proven reserves, and when there will be 1 trillion production per year, and 5 or 6 years down the road, there will be a reduction of gas production in USA. That's very interesting to see what would happen. And it would be quite consistent if we now give the floor to generation ahead, to our young specialists, our future. We are cherishing lots of hopes related to young specialists of ours who are postgraduate of Perm National Research Polytechnical University, Daniil Gurmanipesov, will have his presentation. And the topic he selected for the presentation is very much appealing to me. It's called the Eastern Vector of Development of UGS via the example of Central Asian countries. This is very good because there is a new generation of young aspiring specialists who will be dealing with that. And nowadays the situation has been developing before our very eyes, and we can see what is going on in the Eurasian continent. Dear colleagues, my presentation is dedicated to the Eastern Vector of UGS via the example of Middle Asian countries. Recently, around the world, very big changes have been happening in the global energy sector and gas industry. So this is about energy safety and security for different countries and regions. Mindful of gas industry for energy sector safety and security, all the elements of gas supply should be robust and resilient as an integral complex. UGS is a part and parcel of such a complex. Its role for energy security and safety is very high. UGS supplies gas to consumers amid abnormally cold winters and in emergency situations. Electricity and heat are supplied to vital systems like hospitals and others, so they provide for optimum regime of operations of gas from the trunk pipelines. Comparative efficiency of capital expenditures into creation of UGS shows that the costs for creation of reserves of gas in UGS are 3 times less than when we create similar capacities in transportation and oil and gas. And unit capital expenditures, mindful of the growth of the volumes of gas storage, are reducing, and transportation and production costs are increasing. The volumes of stored gas in different countries depend on the degree of the development and the condition of the gas industry, volumes of import and export of gas, and other parameters. Identifying the parameters for storage for domestic consumption could be seen in countries like USA, Russia, European countries, China. Annual operational reserve in those countries is between 12 to 19% of the annual gas consumption. In line with the calculations, there should be at least 5 or 6% of gas storage capacity in UGS. So we made our assumptions based on that value. Turkmenistan is one of the largest countries when it comes to proven reserves of gas, which are in big amounts. It's among top 5, along with Russia, Qatar, and USA. The current proven reserves in Turkmenistan are about 50 trillion cubic meters. Turkmenistan is number 1 in the world in gas reserves. There's very high volume of production and domestic consumption of gas, but Turkmenistan doesn't have UGS. There were very cold winters in 2022, 2023 in eastern Turkmenistan due to very big colds. There was the failure of the equipment of gas compression and gas processing, so Turkmenistan had to stall gas delivery to neighboring countries. Mindful of the needs of Turkmenistan for robustness and continuity of gas supply to consumers inside the country, to enhance the level of energy safety and security of the country and optimization of infrastructural projects of gas and energy supply, it's necessary to create UGS. It's very, very important for the country. and preliminary assessment was done. So there should be gas volume up to 9.5 BCM, and we need different UGS for internal consumption and to regulate export supplies as well. Despite the fact that Uzbekistan produces big volumes of gas, high volumes consumed domestically create difficulties for export in domestic market. Uzbekistan has got some capacities for UGS, but it's not enough due to extremely cold winter and high consumption of gas inside. Export to China was stalled. In order to satisfy very high demand inside the country, Uzbekistan had to come to terms with Turkmenistan about the supply of 1.5 BCM of gas. There were very cold weather in winter last year and this year, and they were tripping some electrical power capacities and gas supply to the consumers. So for 2 hours daily in some of the regions of the country and in Tashkent, they were tripping some electrical power capacity. We'll have to increase twofold gas supply. Iran now is number 4 largest gas consumer after USA, Russia, and China. They are scaling up gasification of their territory. They increase the gas generation of the energy, which is part of their 7 years plan for the development until the year 2026. But there are some risks that there will be disbalance between production and consumption. Recently, Iran has been scaling up the export of natural gas to Turkey, Armenia, Azerbaijan, and Iraq. They would like to increase export up to 10% of production. For intensification of export, Iran constructs export gas pipelines to Oman. Iran has got some capacities for UGS, but they are not enough to optimize domestic consumption and export. Weather abnormalities impact drastically the Iranian system of gas supply. In 2022, Iran stalled delivery to Turkey for 10 days due to snowfalls and frosts. They don't have enough capacity to produce liquefied gas, not enough capacities of pipelines or capacities for UGS. That way, export gas capacity of Iran is based on resources, but infrastructural component is underdeveloped. According to the system of assessment, there should be a 7-fold increase of UGS capacity. The population in Pakistan has been growing very high, so their economic growth follows that. 4% of 4% of economic growth, but there is a gap between supply and demand. Beginning from 2020, Pakistan has been experiencing the deficit of gas. Some of the gas power plants had to turn to fuel oil into productions and carbamide production. They didn't have gas enough for regular work, and they had to export fertilizers. Pakistan has got a big challenge. There should be energy safety and security of countries. There should be stable price for gas pipelines from Iran and Turkmenistan, and supply of liquefied gas could be a good solution to that. There is also national Pakistan pipeline to connect Karachi and Lahore, 2 large industrial centers of the country. Pakistan would be connected to global Eurasian gas transportation pipeline system, which is very important for energy safety and security of this country. Apart from sustainable deliveries of gas to domestic market, the country may become the transitor of resources and will receive lots of also investments. And it's necessary to have UGS, which is not existing yet. The creation of UGS for natural gas is very important to have sustainable supply of gas for domestic market as well. And it's necessary to optimize the modes of operation of the systems and regasification. At the first stage, there should be at least 4 BCM storage of the active volume of gas, and then it should grow to 6 or 7 BCM. The storage should be close to the centers of gas consumption. Afghanistan is the heart of Central Asia. Its role in gas supply to other countries is very important. Without Afghanistan, the implementation of any Asian infrastructure project is utterly impossible. But their own domestic gas industry is being restored only. Afghanistan consumes about 0.2 BCM of gas per annum, and it uses it to produce fertilizers and electrical capacity. Access to electrical capacity is given to no more than 30% of population and only 15% in rural area. This is so they get supplies from Iran and Central Asian republics. There is the synchronization between Afghanistan and the former CIS countries of Middle Asia and Russia. Afghanistan railroads do not exist as the system. There are some parts of the railroads in different parts of Afghanistan, but they need getting access to Tajikistan, Turkmenia, and other countries, Iran and Pakistan, to the Gulf and to the Indian Ocean. Electrification will require extra gas volumes, which is only available in Russia. Kabul transportation corridor will enhance this ability to create trans-Afghanian gas pipelines. Russian gas and creation of more capacities of UGS in Central Asia will expedite construction of gas pipeline connecting different countries, because for Afghanian goods, mindful of the development of ore deposits, the largest Eurasian copper deposit was high proven deposit. Sangan, it's 1.2 billion ton of developed reserves, and Afghanistan needs active volumes of UGS for sustainable internal gas supply. They'll need 1.5 BCM gas, and then it will be growing. There should be sustainable and reliable gas transportation. So the creation of UGS is a very important element of gas transport system of Central Asia and entire Eurasian continent. So this gas transportation system will unite the infrastructure of railroad, maritime, motorway, electrical grid, and pipeline transport. So Kazakhstan, Russia, Uzbekistan, Turkmenistan, and Iran would be connected to consumer countries India, Pakistan, China, Bangladesh, and others. As the result, gas industry and other types of energy supply and transportation in the territory of Asia would be interconnected very closely. The task of creation of global cross-border transportation corridors sustaining energy and food safety of the countries, strengthening their sovereignty, is a high priority vis-a-vis decarbonization of economy or global green energy, which is disputable as well. Thank you. Thank you very much. Very interesting presentation. I would like to highlight on several things here. In Uzbekistan, Turkmenistan, the way we conjure them, it's very hot, but it turns out that they have got cold winters and snow as well. And in Turkmenistan, there are lots of gas, and they supply this gas. And all the same, they'll have love to construct huge gas system. In Russia, there is plentiful of gas as well, and we export it as well. But we construct huge gas in order to help our domestic consumers. This is interesting, but maybe Turkmenistan colleagues may say that if there is a lot of gas in the country, why do you need those huge gas? And we were surprised by what you said about Afghanistan. It was interesting. Thank you. Well, he's a young, aspiring scientist. As to transportation corridors, this is a very important topic. Mindful of the recent meetings of the leaders of our country and of China, it was mentioned there. Transportation corridors are very important. They are about everything, and also we should mention railroad transportation, motor vehicles, corridors, trucks, and of course pipelines. Yes, this is very right. We still have got 3 more minutes to go before lunch. Let's announce lunch. Thank you very much for your attention. So we break for lunch for 1 hour.
Так, добрый день. Давайте продолжаем, вернее, нашу работу.
So, good afternoon. Let us continue.
Очень интересная современная тематика.
Interesting subject.
Возможность использования существующей газотранспортной инфраструктуры для
Potential for use of the existing gas transportation infrastructure for shipment and storage of renewable gases, biogas, hydrogen, helium, and carbon dioxide. So I would like to invite the panelists to take their places at the panel. Ms. Haydina, Mr. Barsuk, Ms. Abukova, Ms. Safarova, Ms. Khvostova, Mr. Dorokhin, and Mr. Sokolov, and Ms. Olga Golovihina. Hope enough take places. So, by way of introduction, non-hydrocarbon gases, that's what we will be talking about.
Ну, давайте посмотрим, какие, как говорится, дьявол всегда скрывается в деталях. Так все там вроде как красиво, но эти огромные объемы надо где-то хранить. Как правило, скорее всего, это пористые пласты. Что же там с ними будет? И так ли это все просто? Вот поэтому Мария Павловна Хайдина, кандидат технических наук, доцент кафедры университета имени Губкина,
PhD in engineering from Gubkin University, and it is the subject how biogas components affect the rocks, formation fluids, and of the UGS reservoirs. So I would like to welcome all the participants. There are many familiar faces. So let us talk about something which is not significant for our industry. It is storage of biogas. So we made a study, and we received an outcome of the study. We started to study the microbiota of the UGS, and along the value chain from the production of the biogas, and we used to be talking about this, and it is methane, which is extracted from the mixture, which is generated as the activity of bacteria and organic waste. And organic waste could be of different composition. So the composition of the natural biogas, besides having a different fragrance, its chemical status, chemical composition is also different. And so the composition might be different even from the same producers. As far as the chemistry of the biogas is concerned, on the face of it, it is similar to the one we have in our industry, because the generation of organic biogas processes are similar to what we have. But the difference is bacteria are existent in it, so we studied it. And initially, to reduce the scope of work for this study, we developed the methods for the research.
Много лет, начиная с 2012 года, а это большой период, представьте себе, сколько отборов и закачек мы провели.
The starting year is 2012, and the biogas has been pumped into the transportation system. And we hope that there are studies, work that covered the subject matter of the impact of bacteria on the biogas. But it turned out that there are not that many. We performed the desk studies, and we read 400 plus sources, texts, and then it was necessary for us to switch over to the experiments. But in this case, it takes years to make the experiments for the bacteria to respond to the food, to the feed that they will be offered. And we used the UGS technologies, taking into account that we will have the injection and withdrawal. The fluids is the formation water and the water in the biogas. And then we have filters that contain everything that is coming from the formation. And we need to understand what the biota is, and we deduce that from the sludge that is accumulated in the filter, and all these things were studied. Then another subject is gas, and the gas is of triple nature. And we agreed that they will start producing biogas for us, and it turned out that the biogas smells, that it always smells, and it's just like the cow shed. So we studied the gas that is injected and the gas that is withdrawn from the USG, which never contained biogas, and we hope it will never have, because there are so many peculiarities related to the biology. So the chemistry was quite interesting, and there is a balance of all the chemistry, but the microbiology is actually a black box that processes the feed that it receives. That's the material that was handed over from the USG. There are two wells over there, and there's rust, and there's waste, and all the other things. Rust was studied, and the rust was caused by bacteria. I would like to note right away that it was for the first time of our gas chair in the university, and we have been cooperating with the Moscow State University, and I would like to thank Ms. Alice Kerova and her team. And it is for the first time that microbiologists were attracted to the work of the USG, and I would like to thank the other colleagues of the university who have been consulting us, and we have articles published. So we have extracted those bacteria, and it was necessary to cultivate them in the media, in a certain medium. So I will be leafing through my slides, but the essence of the work done is covered by the slides that will be at the end. So there are different methods. We make use of it in our activity. Some of the pictures are known because in 2006 a team collected the microbiological samples, but even those that were in at the fields, they don't remember the work done. But anyway, we collected, did the samplings, we had the cores, we did the coring, but we analyzed the USG that didn't have any natural biological components in the gas stored in the UGS. But bacteria could be present everywhere, but whether they manifest their existence or not depends on the conditions. If they are fed, then what do? They start producing. Why we cannot notice them is that we do not feed them well. And it is the fractions of the CO2 is enough for the gas that we transport, and the hydrogen could be added, and it will be an incentive for the progenation of the bacteria. And the good thing is that we do not exceed we do not deviate from the standards of the gas that is supposed to be transported and stored in the UGS. But anyway, the pictures that you can see just confirms that there are bacteria in the formations that never got in contact with the biogas. And if hydrogen is there or oxygen, and the bacteria will got active. If some bacteria will remain idle, redundant, the others might wake up even in the conditions of the absence of oxygen. So different pictures, if we look closely, we will see that there is a wide range of the bacteria, and our studies shows that pyrites and calcites are over there, something we do not like to be present at our filters. So these are the results, and the UGS hardware is corroded, and the corrosion could be provoked by the existing bacteria, and if the equilibrium in the UGS is broken, the consequences, the effects could be very severe, something that the UGS in Europe have. So the UGS in Europe have developed the deposits of molecular sulfur. That's the results of the living of bacteria. Though then the specialists, the experts, did not respond to the word microbiota, and they were just were not aware, they were not apprehensive of it. And I would like to mention right away that there were studies performed in Europe related to biogas. They are more serious about it, and the work analyze the microbiology, not only the chemistry. This is the photo from the Masaryk University of Czechia. There's Professor Anderkel, who heads the laboratory in the university. So that's the regular standard filter. We did not specifically choose. We made a random choice, and it was just packed into a sleeve to maintain sterility. And we are thankful to the field operators who send us materials. So, and we performed the microbiological analysis, and this particular sample was quite quite clean. It was not contaminated. The black shows the contamination of the bacteria, and that's the breakdown that we have.
Могу сказать, что по этим работам на сегодняшний день у нас есть уже и аспиранты, есть магистранты, защищено 3 бакалаврские и магистерские работы.
Defended altogether 7 doctorates as well.
Фактически это доказывает то, что мы имеем на сегодняшний день новое направление в исследованиях нашего мира подземного хранения газа. Теперь уже вернемся к тому, что будет, если мы добавим биогаз.
So, what will happen if we add biogas? You can see that the oxidization process will be more active. These sulfates in the presence of bacteria. That's it's just a metal pin, and if you see the middle picture, it shows that this particular pin is intact, but the bacteria over there, then you could see that it is all black. And I would like to emphasize that the gas transportation system, both in Europe and in Russia, was quite all right in terms of bacteria presence. Because the gas from the Russian fields was not contaminated. It met all the necessary standards. If we talk about the hydrocarbon storage and unconventional gases, and by non-conventional I mean helium, hydrogen, and CO2, which is supposed to be stored underground. If CO2 is stored, it will provoke the activation of bacteria. And 2 test tubes over here. One had natural CO2, so we could only expect the genesis of microbiota, pathogens, and the picture to the right shows the UGS, and there is a control test tube. It's just the medium, the culture. The left and right has CO2 added, and you can see that the reaction is accelerated. The turbid yellow is the activated bacteria pathogens. We can expect that if there is CO2, then the hydrogen molecules will be generated depending on the thermobaric situation. And the thermobaric conditions in the UGS in Russia are good for the life of all the bacteria that can produce all those bad things. And then, as a result, the gases will be more fat.
Обычная привычная картинка. У меня это всегда студенческие работы. В данной ситуации это исследовательская работа. Тоже студенческая, это магистерская работа. Мы смоделировали на однородном пласте, как мы любим, с куполом характерным, с составом, с ПВТ-условиями, характерными для наших ПХГ. Мы смоделировали отбор-закачку сложного состава газа. Сразу скажу, что это называется произведенный газ у нас, потому что не 100% прямо вместится в компонент.
It does not include all the components of biogas, because I hope that
Но, тем не менее, вот там, даже тех примесей, которые останутся, может происходить всяческие химические реакции, в том числе распространение. И вот с помощью программного обеспечения этот навигатор, который для многих из нас явился новым, ввиду некоторых событий,
microbiology could be
то выяснилось, что есть эффект накопления. Раньше у нас в дипломных работах изучался эффект накопления, связанный, например, с тем, как будут себя вести газоконденсатные месторождения, настоящие подземные хранилища газа. Там мы тоже видели эффект накопления, когда, допустим, мы заполняем газом, очищаем от природного, того характерного для этого места газа, нашим
and we
магистральным
clean it
газом, и на
from
какой-то момент
the
времени у нас
gas
повышается
that
конденсат на 6.
existed in the
Причем
reservoir,
не сразу, а
and
замедленное действие.
we
Так же, как и здесь, мы
witnessed
увидели,
the
что
recovery
моделируя
of
химические
condensate.
процессы, которые
We witnessed
происходят
the
именно
similar
благодаря бактериям,
processes
то
over
есть
here.
через
There are
магистр,
processes
который выполнял эту
caused
работу,
by
он
bacteria,
очень
and the
скрупулезно
master
отнесся к этому. Он написал
student
отдельные ноды,
was
все
very
навигатором он имел
meticulous,
вообще
and
самые
he
там близкие
used the
отношения. Он замучил всех
navigator,
консультантов, Европу Dynamics, компании, которая производит это программное обеспечение. Вы уже, по-моему, звонки они воспринимали уже как само собой разумеющееся, они даже с ним встречались. Вот они воспроизвели это все, и студент огромный проявил усидчивость.
And the student was so persevere that he made such a slide, with some overlaps.
Это у нас как бы конец нашей
So
истории.
you can see the end of the story. 2017, the effect of accumulation is such that those gases would be felt at withdrawal. They would border on the admissible norms for transportable gas. Our gas purification system is not just ready for its conclusion. So we'll have to do more surveys. For a year ahead, some of the bacteria were collected from the injected gas, and unfortunately, they are there. They go through the pipeline. These bacteria are not dying out. We keep transporting them, and we keep mixing up this microbiota from one field or UGS from one to another. This is typical for our UGS system. But we managed to cope with technology-wise, but provided we just destroy this balance, we'll have to redefine the norms. The norms in Europe for UGS were reconsidered 3 times. Finally, they maintained that the gas should be fed to the pipeline, which is in line with Russian norms and values, but neither component. We admit that they could be inside our transported natural gas. We never ever reached the ultimate permissible values. We kept to the lower threshold. We had more clean methane, and in Europe they maybe will use the average value of microbiota in their transportation system because their microbiota is also transported through their pipelines. That's the information out of the Western world. Main producers of biogas in Russia, as you have seen in the last slide. Thank you. I would like to recap on what you said. This entire work was done because in Europe there was an upswing of popularity of biogas. And in the very beginning, there were no constraints. They were commissioning a trunk pipeline, and biogas was going through this pipe. As to Russian gas, there were stringent constraints on oxygen for Russian biogas. But here we can see hydrogen, sulfurous hydrogen, and CO2. Then there is sulfur emission, and there are ulcers, corrosions on UGS. Whose fault is that? They were grappling with our pure Russian natural gas. Instead of that, they ended up with this biogas adverse impact. At Gubkin Oil and Gas Academy, they studied this issue very thoroughly and found many very interesting things. All those efforts did not go down the drain because there are lots of very important conclusions drawn from this. Nikita Barsov had all the Department of Gazprom. Once again, good afternoon, colleagues. I made a point about the topicality of the green agenda, or rather about sort of fading out of the topicality of this. And to recap on what previous presentations were about, I'll remind you that in 2015 in Paris, 119 countries signed a binding agreement, Paris Agreement, to abate those emissions, mindful of the global warming by 2 degrees. But the task of this presentation is about other things as well. We should figure out whether the proposed solutions are realistic when it comes to hydrogen agenda. And first of all, from the technical standpoint, whether they are feasible. About 70% of costs to create hydrogen economy would be for transportation and storage of hydrogen. This is the slide of our Department for Energy Development. There are 2 ways of obtaining hydrogen: using natural gas to separate hydrogen and carbon and methane, or use water as the stockpile, or using electricity to separate hydrogen and carbon. About 70 million tons of hydrogen is produced annually for different ends, and the source stockpile is natural gas, oil, coal, water, electrolysis. 96% of hydrogen now is produced from fossil fuel, mostly by steam reforming of natural gas. Partial oxidation of methane, and only 4% out of water and air. In steam reforming of methane, to produce 1 ton of hydrogen, we have to produce between 9 to 12 tons of CO2. That's the so-called gray hydrogen, which is rather inexpensive, about $3 per kilo. Methane pyrolysis, and Gazprom is maintaining that there is no greenhouse gas produced. It's production of 1 ton of hydrogen that will bring about 3 tons of solid hydrogen, turquoise hydrogen as it's called. It could be sold as the stockpile for further production. Major issue with electrolysis is about the fact that electric generating units have got the efficiency of 21% only. So at the end of the day, we're using 4 units of energy in order to create 1 unit of hydrogen energy. Apart from that, hydrogen made out of water using electrolysis is 3-fold more expensive. Price comes up to $8 to $10. So this is very expensive, even if it's $2 or $3 per kilo. That's high cost for consumers in Europe. Green hydrogen obtained using renewables could cost just outrageous $15 per kilo. Show me the guy who's going to pay through his nose for that. Mindful of hydrogen energy, some commercially valid technologies of hydrogen production envisage big volumes of CO2 as a byproduct. And with the increased volumes of hydrogen production, correspondingly, there will be a scaled-up growth of CO2 volume. There we go again about recycling. We're using those huge CO2 volumes. What should we do with them, one way or the other? So it's like in Jerome novel, Thames is not feasible and not expensive enough as we use its energy. So there are no UGS valid for this purpose to capture and store such huge amounts. But information conditions, CO2 could be in different aggregate conditions depending on temperature and pressure whether it's liquid or gaseous. Liquid is better for storage. It will be in compact condition. In a formation, you can store more volumes vis-a-vis just gases. As to replacement of buffer hydrocarbon gases, it should be supercritical condition because it's in its form. It's a gas in viscosity. It's fluid. It will be high density of CO2 and gradation or separation of methane and supercritical CO2. Global utilization of CO2 from hydrogen production aside huge volumes for storage. It will also require high-scale scientific and technical feasibility study and very significant costs. Stock taking on those tasks for production of hydrogen, such technological and economic solutions should be taken on board so that the cost of production of hydrogen should be no more than $2 per kilogram. It's not cheap at all, but it's cheaper. And as to carbon footprint, it would be no more than 4.5 CO2 equivalent per kilo of hydrogen. Volume of investments, it's not dozens millions, not hundreds millions, not trillions, but dozens, trillions. We're talking very big money here. And we found a report from Bloomberg, and they say it will be hundreds of trillions. So, is there such a huge amount in global economy, dozens and hundreds of trillions to create all that? I am doubtful. Active injection of hydrogen into distribution grids also raises lots of question marks due to adverse impact of hydrogen to different materials, mindful of adverse impact of hydrogen for some plastics and some grades of steel vis-a-vis natural gas and different requirements for sealing and tightness of the equipment, specialized dedicated regimes of compressor equipment in pumping and repumping of the hydrogen. So we can assume that the use of the current system of natural gas for transportation of hydrogen, it's utterly impossible without extra R&Ds and feasibility study of using different materials, equipment, technologies, mindful of the fact that methodology of such studies and substantiations is non-existent yet. Then there should be lots of different standards, legislative acts, and so on taken on board in order to provide for very specific technological hydrogen safety. So just the other way around, methane is underneath and hydrogen is above, or it's just the other way around. So everything's so different. We'll have to put together lots of endeavors to put together rules and standards for hydrogen transportation. Regulators of many European countries yet do not identify the ELVs for hydrogen concentration or provide for different ELVs. European standard says that ELV for hydrogen and natural gas pumped via the pipeline is 0.5%, or a German standard identifies the content of hydrogen and natural gas in different situations. General requirement no more than 10%. In compressed natural gas for transportation no more than 2%. And the gas used by gas turbines between 1 and 5% gas pumped. But those ELVs oftentimes end up being utterly pointless because flow meters are not capable of efficiently identifying concentration of hydrogen in the flow of natural gas. So sometimes those concentrations are not controllable and they achieve an admissible level of 15%. The impact of hydrogen upon ground-based UGS equipment is very much akin to the described processes at the pipeline transportation. So we should think about, well, equipment hydrogen penetrates the elements of structure such as elastometers and steel and concrete and damage it. We have got very little information about such damages, but we should think about wellhead equipment, safety valves, and other equipments for using specific grades of cement, let's say, which might entail high-scale tasks for redrilling the entire well stock of UGS. UGS, especially those which were developed, which were created in depleted gas fields, are another system. They live on their own account, bacteria and everything. Bacteria might be dormant, and then something happens. Hydrogen pumping fully destroys the stability in the underground medium. Hydrogen reacts formation fluids, rocks, minerals, and by the same token, as Maria said, that with bacteria, first of all, nobody brought this up before, and the situation is aggravated by the fact that along with the hydrogen, also sulfurous substances could go there and alien to the formation bacteria. As the result, adverse processes could develop in the formation. The loss of stored hydrogen due to its biodegradation and solution and formation water increased the acidity level in formation waters, contamination by sulfurous compounds as a result of sulfurous hydrogen as the product of consumption, and all those processes are understudied. 20 years ago, we started talking about it, but then we lapsed into silence only maybe several years ago. We restarted discussing all those things, and so some of the professors of the Western world actually informed us that those processes are underway, yes, but they are understudied. As a result of destruction of geochemical and biochemical equilibrium of the object of the storage, there could be corrosion processes, aggravating bacterial corrosion, first of all, biofilms of biosulfate reducing bacteria under which this acidic medium would develop corrosion as the result of activities of sulfate reducing bacteria nutrient by the hydrogen. It could be 100 ppm. It's a lot. As to biogas, biogas production has been scaling up around the country. It's turning into one of the components of the energy basket. The source of biogas is a biomass. So, correspondingly, we are going back and forth and discussing the situation, and I think that we might say that we have got lots of ex-partners from the Western world, and they used to say that biogas is a renewable stockpile. Biogas is announced a renewable gas, but as to it's not environmentally friendly, well, that's another thing. According to the journal International Bioenergy, 86% of biogas potential is in agricultural stockpile, only 8% in the industrial, utility, and household waste. So biogas has been developed from organic residue of agricultural production and agricultural electrical energy cultures, like we call them. On an annual basis, more than 60 BCM of biogas is produced. Asia, India, China, Vietnam, and Nepal are leaders here. Altogether, it's about 30 BCM. Europe produces 16 BCM. Out of that number, only 2.4 BCM it's purified by methane. America produces about 10 BCM. These 2.4, the purified not biogas but by methane. Our European counterpartners are pumping into unified European pipeline, and so it goes around UGS as well, and they don't take any pains to divide those flows. Economic solutions should be taken on board to make a better situation. So the cost of 1 kilowatt hour produced using biogas, it should not be more expensive than generation of electrical power capacity using natural gas, if you want to be consistent about it. Having said that, under the acceptable level of impact, that is the reduction of emission of biomethane and gas treatment and so on, should be done depending on the stockpile and production technology. The composition of this biogas could be different. Most part it's methane, of course, but there are big quantities of oxygen as well, up to 3 molar percentage, and CO2 in the amount of 50 molar percent, sulfur 6%, nitrogen 10, steams water also 10, heavy hydrocarbons, and bacteria as well.
So, as a result of injecting such gas into the pipelines and the UGS could be unpredictable, and the presence of even share of the percentage of gas pumped into the porous environment could result in interaction with the different agents over there, formation of water, and this interaction could result, even when there is little water, which is a catalyst. As a result, the bacteria generate in the favorable formation conditions. They generate sulfur, and sulfur deposits negatively affect the technological parameters of the DGS. There is calmatation of the porous space, and the sulfurous deposits are on the filters, valves, cause corrosion, and sulfur results in degradation of the silica gel, and it's a very costly material, and sulfur degrades it and killing it, wasting it, and a few years and tons of silica gel will be spoiled. And we calculated the service life of the silica gel in one of the UGS, and its service life is expected to be 10 years, but it actually stopped being active in 5 years. So even the compressors could be made unoperational, and as a result, they remove the man compressors. And I'm a biologist by education, and I might not understand something about compressors, but doing the overhauling repair every 3 years, that's ridiculous. And when they open it and when they disassemble it, they can see corrosion inside. And they said, no, well, we don't know why it's so corrosive. We explained them why, but they are not sure. And up to 60% of the productivity of one of the European UGS was lost. Since 2016, the European UGS has developed the technological problems with the rise of the hydrogen and degradation of the silica gel and the hardware becoming inoperative. So these are the huge problems they face. So there are different issues that arise at the transportation system and storage system, and all these problems will need financing to overcome it, to address it. So it is necessary to study, to invest money, to ensure the smooth operation of the systems using biogas. Productivity factors, efficiency factors of the hardware producing hydrogen is low, and the storage system efficiency factor is low, energy is lost, and under these conditions, the only tool to ensure stable supplies and to ensure the energy security are specialized UGS, not the existing UGS, but the specially designated UGS should be built for, it might be the salt rocks quarries that could be used, and if they are specially designated, then the storages and the pipelines will have to be built, but then the question mark is how much it will cost. So I can only reiterate that hydrogen should be cheaper than $2, and the production of biogas should be not more expensive than the kilowatt unit cost produced using natural gas, and taking into account the effects of using hydrogen on the transportation system used for transportation of natural gas, it's not advisable to use the system without additional research, study, development of these standards. So the possibilities for transportation gas are limited, taking into consideration the existing negative process. So technologies, approaches, infrastructure, and materials are needed. So the contamination of biogas with the adverse components make it impossible to transport the biogas using the natural gas infrastructure. So if you want to transport it, then you should use you should make the studies and use the proper materials and technologies. So that's, in brief, these are the bullet points. Thank you. Please take a seat. Ms. Leila Abukova, doctor of geology from the Institute of the Russian Academy of Science, and the subject matter is detection of processes that take place during the joint hydrogen and methane storage in underground formation.
Дорогие, после Никиты Евгеньевича Высокого надо привести.
Nikita is too tall. I will have to lower it. So, good afternoon, dear colleagues. So, you have the title of my presentation on the screen, and I will give you some figures and formulas, what was mentioned about the hydrogen. In fact, I will build my presentation on what he has stated. However, I would like to emphasize that the work that I will be presenting have received the funding, the budget allocations from the state, and it is submitted for the expert review of the Russian Academy of Science. So, we have been dealing with that for 3 years. And we worked along the similar lines that the Associate Professor Haidina mentioned. And as a result, we believe that we have developed the methods to study the microbiological effects, implications that might occur if the UGS are used for storage of hydrogen methane mixture. I would like to emphasize that it is important because we have heard it even in the first presentation that it is not possible to segregate the microbiological and the chemical effects. They are intertwined, and it is necessary to work with natural media. It is necessary to have a repetition of the experience to get the deliverables. However, we have developed the methods. I will be talking about the geo and hydrogeochemical parameters, and then the other parameters will be taken up by the other speakers. You might have seen already what the research methods include, and some of the approaches are novel, are quite new, not only for this particular problem, but with respect to the geological methods. We use light dissipation, microscopy, and we have determined the genome characteristics of the microbiological communities that we study. And not all the methods have listed over here. For example, mathematical modeling have been used to study leaching or deposition that are provoked by artificial introduction of hydrogen into methane, and on the whole related to the positioning of the methane hydrogen mixtures in natural environment. So we have been analyzing the methods, and we have determined the hydrological and microbiological factors connection, and we have chosen the environment that are typical for the UGS that are located in the aquifers of the Moscow hydrological basin. So these strata, these locations are indicated over here. We have used the Pestchano-Umetskoye UGS, and we studied the sulfate reduction processes in Pestchano-Umetskoye UGS, and different to what we have been reporting last year. And I will talk about the manifestations of the rise. studied the processes that were supposed to be more manifested, being of passive nature, but I will show you what are the outcomes that we have received. Please pay attention that I'm talking about the formation of water, and they are quite different as far as their chemistry composition is concerned. Please pay attention to the pH. It is pretty close to being neutral, and it is an indication that while these waters didn't receive any human-caused load. But even these waters in the Moscow hydrological basin, and there are no gases over there, with the exception of small gases. This is a pure basin, and there is no hydrocarbon generated over there. However, surprise as it was, there are both volatile and non-volatile organic acids. And organic acids was the main actor in the processes that I will be talking about. And we will be talking about highly mineralized water. And back to the pH value, which shows that some of the areas have the reduction processes, and there is a hydrochemical neutrality, but there are processes that indicate that the reduction processes take place in the rock. So, the values, the absolute value of the organic acids was not high, but there are some other UGS in proximity to the gas fields near Stavropol, and the values are much higher. And this is virtually an answer which facilities are preferable to store hydrogen and methane. Hydrogen and methane mixture. And for us, it's another indicator not to overlook the hydrochemical criteria. And that's why we suppose that in the future we will study this particular area. I mean, we will be studying the organic component of the underground water. The slide shows the description of the processes that result in the effects, and those effects were mentioned in the previous presentations. The organic acids interact at stage 2, at the second stage, and please pay attention that the disintegration of the organic acids, and the second part of the slide shows it, results in the consecutive disappearance of hydrogen. And hydrogen is used for the reactions of hydrolysis of the organic acids. And in this case, we have
уксусной приходится
we
8
have 8
молей водорода, и при
moles
этом
of hydrogen for vinegar acid and 8
позиция уже говорит
molecules
о
of
том, что
carbon dioxide are produced. And then it is an indication of what chemical agent results in the disappearance of hydrogens. These waters have a lot of organic matter. And stage 3 is well covered and well studied. And
выраженный процесс — это, конечно, процесс метаногенеза.
Most obvious process is methanogenesis process, and there is another problem related to it. It is hydrogen loss as a result of the methane production, methane genesis. And in this case, if there are methane hydrogen mixture storage takes place, then hydrogen will be lost and methane will be higher. So it's a reverse process economically. As far as CO2 is concerned, indeed, the hydrogen genesis is accompanied by higher CO2, which should be disposed of one way or another. But the things are not that easy. Much depends on the environment. We can witness some reverse processes. CO2 could be absorbed. And another slide will demonstrate it as well. Please pay attention to line 4. And it is actually the most significant one. It is a key. Hydrolysis. It describes hydrolysis of organic acids. And this ethane, water are produced in CO2. So what kind of water that? It is human-caused. There are materials that have been published to study it.
It's quite aggressive, and towards this end, its appearance is alarming from the standpoint of its volumes and chemical composition. CO2 and methane are there as well. So these are the problems which could evolve when there is the hydrogen and methane pumping into aquifers. Once again, I reiterate that now we're not talking about low mineralized waters. We're talking about high mineralized waters, mineralization at the level of 150, 180 gram per liter. This is in affinity to saline structures. And this should be thoroughly scrutinized as well. I have a rhetoric question. Is it possible at all, in the first place, to have this kind of hybrid placement or hybrid storage of hybrid gases, even if in high mineralized waters? This is just the formula. This is just the probability. As to the reality, we should do high-quality monitoring before, so that adjust and control the situation by hydrochemical and microbiological methods.
Вот некоторые картины взаимоотношений микробиологических.
Here are some biological community, the Peshano-Metan-Kasimov UGS.
Участие бразильщиков, которые, по сути дела, для которых
So we can see those definitions of A or B, different aerobic, organotrophic, bacterian. And we see the structures which give rise to methanogenesis. And simultaneously, there are some products of decay, and also we can see aerobic metallotrophic bacteria. So we can look at this food chain, and we can see sulfate reducers and methane genes. And we can figure out the probability of development of biological corrosion per se, and also sulfate corrosion and carbon corrosion altogether. Here is this probability. That is the content of hydrogen and methane in the composition of the gases, soluble in formation waters. I know that we're tight on the agenda, but bear with me slightly longer. So we have collected big amounts of statistical data which is valid. Same in nature. Hydrogen and methane are directed oppositely, and these two gases act absolutely differently in the opposite directions, so to put it. And here you can see the content of hydrogen, methane, and the composition of gases soluble in formation waters. We look through big amounts of material in sedimentation ponds, and we look at Devonian depositions of bitumen and bituminous coal sedimentation in eastern Zhigulov region of Pavogia. You can see different volumes there and different boreholes. So microbiological factors impact very big amounts of physiological objects, and they impact different situations related to that. That's what I've been meaning to tell you. So organic acids, then hydrolysis, all those processes, and there will be hydrogen. Their hydrogen will enter the reaction with oxidized sulfate. It will reduce it and so on. It will be autotrophic sulfur reduction. It will be a very aggressive form of sulfate corrosion developing. What did we manage to do? We performed the genome analysis, and here are the results of sequencing of the samples of formation water. This is very important development of ours. The composition of community of formation water. You can see different fields here, and Cholkova field, and in both fields we obtained analysis which are indicative of the fact that microbiological communities were formed along with formation waters. So you can imagine that they were in a condition of rest for very long. They are in conformity with the basin of sedimentation pond. In the middle, you can see hydrological and hydrochemical analysis and different indicators of that. So these are the waters of marine basin of sedimentation pool. We compare previous genomic analysis to our new developments when we use any UGS, be it aquifer or the object for pumping of hydrogen into it. To my way of thinking, it's a fancy biological way of doing monitoring. Interesting results were obtained by us quite recently, results of sequencing of the samples of formation water. I disagree that we don't have enough materials and developments and articles about hydrochemical composition and hydrochemical studies of this process. Of microbiological impact upon the hydrogen. They are available and they are even plentiful, but another problem is to systematize them and to include them into our range of studies. Scopus indexed over the recent decade about 12,000 different publications on storage of pure hydrogen and hybrid hydrogen in much less quantities. As to hybrid storage is just a handful of publications. Nonetheless, oftentimes, it's mentioned in our literature, in our publications here, that the optimal combination of hydrogen and methane mixtures is 10% to 90%, but our results are different. You can see those bars in the left-hand side of the slide. It's the number of DNA cultures grown using different gas phases. And here you can see 4 different variants. First one is 90 to 10 ratio, then 85 to 15, then 80 to 20, and of the pure hydrogen. It's a linear difference, linear reduction of the amounts of bacterial masses. They are more typical for those values which are most oftentimes recommended as optimal ones. That is the technological feasibility and substantiation but from the microbiological standpoint, it's the worst, the most inferior of all. We should keep that in mind as well. Because it's very important. 2 small bars here. It's 100% CO2 and 100% nitrogen. Chinese researchers said that they're using nitrogen as buffer gas. I think this is a very good solution from the standpoint of bacteriological situation. Mindful of microbiological methods, oftentimes we keep hearing different doubts about repeatability of the results. That's the way it is. It's a labor-intensive way of doing things. It was a long and winding road for us in our studies, but we made it. First of all, for the first time ever, we have used the methods related to light microscopy, which enables us to identify and record the amount and the growth of microbiological colonies in media in real time. It's a unique equipment developed on the grounds of our university for other purposes as well, but we use that in our analysis. It's highly informative. And so you can see this experiment when we add up extra portion of hydrogen as nutrient medium, it drastically increases the efficiency. Although the graph on the left-hand side shows the situation, it should be without hydrogen. It's a conventional, commonplace life cycle of any system: growth, stabilization, and death. This death will never happen if we keep on adding up hydrogen. Of course, I mean it jokingly, but in point of fact, aside highly informative characteristics of the method, it also shows that it's very effective medium for sulfate reducers in this particular case. So those processes will be displayed throughout the process. I'm about to wrap it up. On the right-hand side, it's the same which I meant. On the left-hand side, it's the time since the beginning of the experiment. So it's a repeatability of the experiment because we prepared the methodology for analysis in a very thorough way. We knew exactly what we were going to do every step of the day throughout the analysis. Of course, we should fine-tune every stage of the experiment, but we accomplished a high degree of convergibility of the results, which enables us to say that the methodology of experimental studies of joint impact and microbiological and biological factor is around, and we accomplished very robust methods of their identification. That about wraps it up. And here are the conclusions. So theoretical substantiated and experimental supported is the aggregate role of transformation of geological medium. We suggest methodological solutions to assess potential adverse impacts of mixed storage of hydrogen and methanes. That way we reduce the risks of the reduction of hydrogen mass. And we saw that in UGS, there is a competition over food resources for a big class of microbiological community. It's hydrogen, which is playing this role. So hybrid storage of hydrogen and methane should be critically assessed whether it's expedient in the first place, and we'll also develop the methods and biological methods among this number to mitigate the risks of hydrogen reduction and emergence of corrosion. Thank you very much. Thank you.
Пожалуйста. Сафарова Елисавета Александровна, научный сотрудник Института проблем.
So, Ms. Safarova, Russian Academy of Sciences, the Institute of Problems of Oil and Gas. So, I would like to say that unless we store hydrogen for laboratory studies, but for industrial usage, we should store very big amounts. UGS in salt rocks, it's not a good way out. They understand that in the Western world. They're going to have an experiment to pump into small size storage. I think it will be with methane. They'll pump hydrogen with methane, about 30 MCM, I think. But I'm fearful that this presentation prompts us that nothing good will come out of it. Microphone is not used by the previous speaker.
Понятно, спасибо.
I've got it. Thank you. Елисавета, I'll be brief because we're behind the agenda. My presentation will be about demonstration of results of studying of prevention of conversion of the impact of the hydrogen underground and pumping into mixed storages of hydrogen and methane. Such an approach to hybrid storage was articulated a short while ago, and there are some transformations of the rocks by those gas mixtures. So it's the pilot study. Such an approach, mindful of hydrogen agenda, means that there will be a mixture stored by pumping. Hydrogen is a natural resource now, so this topic is very interesting. You can see the purpose of our studies. We studied the principles of conversion of reservoir rocks in the thermobaric conditions, which are different. So their joint accumulation could give rise to anabiotic processes with some adverse impact as well. In our work, we studied the samples of sandstone. We were making cylinders with 1 centimeter diameter. We were placing them in titanic cell we developed together with our laboratory of the Institute of the Problems of Oil and Gas. We exposed the samples for 2 months. It was quite correct and in line with technological cycle of UGS. And after removal of that load, we measured some indicators on acoustic properties, petrophysical and mechanical ones. Here you can see some of those studies and tests. When it comes to the velocities of elastic waves, samples with periods and clay inclusions along the longitudinal and cross-sectoral velocities increase their values after removal of the load and after the exposure of hydrogen-methane mixture. Percentage is 10 to 90 in our studies. So we studied them further in great detail. And we saw that man-made and technogenic transformations of sandstone due to pumping and exposure in methane hydrogen mixtures are in conformity with dislocations of the rocks. Rigidity of the sample was increased due to that. There was the absorption line displacement. Some defects disappeared due to hydrogen. In change of the structure of the crystal, the volume is changed, which impacts strength and other characteristics of the sampled rock under forcing. And we made comparisons prior and after the experiment of our rocks, and we can see that ferrous sulfides are transformed, periods are dissolved, and we can see also that calcite does not withstand to solution. Quartz and feldspate are quite inertial in this situation. This is another vector of our works, and we also did the studies and analysis in monomineral aggregates separately, quartz grains, smectite, clades, feldspar, and others. We looked at all the conversions and transformations.
Here are the results comparison in our institute. The work was done by 2 laboratories, and petrophysical transformation was studied, and we measured the change in hardness compared it with the sandstone taken from the other UGS. What is important that there is a solidification of the samples, and elasticity modulus, Young modulus is changing as well, and you can see it over here. Thanks for your attention. I can see that we are pressed for time, and we should monitor the physical and chemical property of the solid phase of the rocks of the reservoirs, so monitoring the rocks inside the reservoirs and inside the UGS in conformity with the roadmap, if those UGS will be chosen for injection of the gases of specific composition. And it is possible to evaluate, to measure the impact on the environment if we have the specifics of the UGS. Very interesting presentation. Of course, when the project is developed, particular facilities should be studied, but the general trend is clear. Not everything is that simple as it looks. And next speaker is Ms. Vera Khvostova, and it is technological aspects of related processes at carbon dioxide capture. We are from Gazprom Vny Gas, so I will be talking about the technological aspects of the related processes of carbon dioxide capture. We have been working on aspects of the CO2. We studied it as a 100% component, and then we studied mixtures of CO2 with other gases. We presented the results of our work and studying the ion composition of the formation water and pH and the effects of the CO2 on cement as far as strength is concerned, and also the effects on the formation water. We have published reports and volumes of scientific papers, and since 2008 we have been updating the materials on CO2, and we added our work on helium and hydrogen. We keep updating it. We keep updating the database, and we hope to publish the database of non-hydrocarbon gases. And so it is a more general term. And so there is a lot of reference to CO2, and even today I won't be talking about the effects of the chemistry on cement, water, and metals, because when the results are published, the most important thing for us as those who are engaged in the experiments, what we are doing with our hands. So when we are discussing our results, we start with what we do, in what conditions, whether it was static or dynamic. And since there's a lot of discussion going on about CO2 for the past, not only for the past 20 years, but since 70s of the previous century, when the climate change became obvious, there are 432 projects. Some of them are historic, they are mature, some of them are new, some of them are planned. And I'm not talking about only capture, transportation, and injection, but all the scientific work on CO2 that is done in the R&D Institute. And if we divide 432 projects, then 227 projects of these are are related to capture, transportation, and either storage or utilization. There was an abbreviation which was used some 10 years ago as CCS, as carbon capture and storage. And they haven't been referring to usage of CO2 to generate, to fabricate some new products, or to use CO2 in some technological process. And right now, all the sources, including the reports and the presentation, they have the CCUS abbreviation. So it includes usage or utilization, because there is an emphasis placed on the utilization rather than just storage. But storage as well, of course. Now, in 2023, there are 27 projects to utilize CO2 to produce some kind of products that could be commercialized. And there will be a slide describing how CO2 could be used. Or CO2 could be used for enhanced recovery, injecting it into formation and to recover more coal, methane, or oil, or gas. So there are 27 projects. There are active projects to enhanced recovery. As far as storage projects are concerned, there are full-cycle projects from source, then transportation, and all the development for injection. There are 12 projects like that altogether. And as we are aware, there are no storage projects, just pure storage projects in Russia. And Russia has been ignoring CO2 injections, but applicable law has been developed, and now the highest emitters will have to report what their emissions are. And if the emissions are too heavy, the emitters might be penalized, and we need to know how much CO2 is produced. So it's either to utilize it or to inject it for storage. One of the major sources of CO2 in Gazprom are gas-to-chemistry projects, gas processing facilities. This slide shows the location, the positioning of the major gas processing facilities and the volumes that could be produced if CO2 is emitted in the course of gas processing. The projects are Ust-Luga, Portovaya, Astrakhan, Urengoy, and altogether there are 2.5 BCM. It's not only the CO2 derived from the natural gas. We know that natural gas might contain CO2, but it is the extraction of CO2 from flue gases at the processing facilities. There are a number of the technologies to capture CO2. They're well known. And some of them are new, state-of-the-art, and they're being implemented. One is membrane method, and it is the calcium loop, and it is using the melt of the carbonates or biological methods using bacteria. The membrane method, absorption method, it is being developed, quite costly though. However, this particular method is being used by the businesses. The most widespread is absorption and cryogenic method of extracting gas from the flow of natural gas or from flue gases. We understand that flue gases is a mixture of many components, and most of all, it has a high content of oxygen and nitrogen. And to extract CO2, even if it's not that much, then in the flue gases, and many of you might have read or saw it, that if we take the gas pumping unit, then CO2 is 2.5, but there is a high content of oxygen. It is 16%, and oxygen should be eliminated one way or another, because it will damage the equipment. And if we take the heat generating industry, the content will be there higher. There are major technologies, the basic technologies to eliminate CO2. It is either to capture it before burning the fuel or after the fuel incineration. And pre-combustion or post-combustion processes, and then some of the sources write oxy-fuel combustion. It is combustion together with the oxygen, and so the oxy-fuel is a separate entity, because the oxygen content is very high, and the equipment will have to meet strict requirement. It is not widely spread. The first company was Schwarzkampf in Germany. They used the oxy-fuel technology, but then they closed this particular area of research. And then they injected the resultant mixture into the underground. There will be a number of slides. I will not be talking at length about them, but that's the charts that we have developed. Our team did it, and we tried to study what are the areas where CO2 could be generated, since much emphasis is placed on hydrogen now. So we analyzed where CO2 could be generated when hydrogen is produced. This particular flow shows the major sources. It is when fertilizer is produced, and this slide shows that there are many sources with generating flue gases, and CO2 could either be utilized later. It will be possible to liquefy it and then transport it, or then ammonia could be used to produce ammonia fertilizer. As the fertilizer industry generates a lot of CO2, not only from the flue gases, but when generating urea, carbamide, urea, etc. And this is carbon dioxide in the energy sector. We know that different fuels are used in the power generation, and it could be gas condensation depending on the turbine, either gas or steam turbines or combined hybrid types when using natural gas, and there are two types of turbines, both gas and turbine, and DSCC when the coal is gasified, and synthetic syngas is used, and the CO is either oxidized to generate CO2, and the CO2 could be transported as a result. And hydrogen, the resultant hydrogen in the combined cycle, something that is well developed in the US. There are many power plants in the US that use coal are being transferred to combined cycle technology. Hydrogen is used to run turbines. However, the concentration is less than 10%. And all the rest gases for the turbine are either air or nitrogen. When we talk about the use of hydrogen for heat generation, then we should be aware that the turbines that are using hydrogen, it is necessary to generate hydrogen, and the biogas is CO2 through steam reforming or different types of reformings. The technologies are quite a few. And Italy had an experience. They tried to run a project at Fukushima power plant, and hydrogen was generated when in the reforming of methane, but not much hydrogen was used, and the cost of the energy was very high. That's why they closed the project. And Siemens and former General Electric are trying to develop the gas turbine that might be consuming 100% hydrogen. But for the time being, it has not been designed yet. I mean, in power generation. So it needs the mixture of less percentage of hydrogen. And it should not only work on hydrogen, but produce electricity, and it should be quite costly. Where else CO2 is generated? It is in production of bioethanol. There are many projects in the UK, in the US, Brazil, even Paraguay, South America, but still they have running projects, and their number is increasing. They make the feedstock having starch or the other organic matter, and they generate CO2, and they use it in the food industry, producing drinks, or CO2 is used for enhanced fluids recovery. This is the flow chart of the cement industry, and the CO2 could be produced at the production. It shows the dry method of producing cement and using hydrogen. The process include flue gases, and the CO2 is more than 15%. 20 or 25, and the higher the percentage of the CO2, and especially if it is higher than 20%, then the equipment will be not costly. And similar to the power generation, the CO2 in the power generation is between 8 and 12%. And consequently, it is too difficult and power consuming to capture CO2. And another slide.
Here you can see the utmost volumes of CO2 we can get. That's for metallurgic industry. And there are some projects around and some projects underway, especially in France. Total has been dealing with its CCS but not on blast furnace technologies. Many metallurgical companies are shifting towards direct reduction of ferrum using hydrogen. They use hydrogen for reduction of ferrum out of the ore, but nonetheless, there is a CO2 emitting which should be captured and also transported and stored. Here are the technologies of utilizing CO2 and CCS technologies. It was an eye-opener for us because there is a plethora of small-scale projects when CO2 is used for carbonization of concrete and concrete mixers in Canada, in US, in Europe. There are lots of such projects. Then carbonized concrete is much stronger and it's used for construction in India. All the projects related to CCS technologies, it's aimed for utilizing it in food sector. Let's set some beverages in Japan. They grow algae and make different biological additives and supplements for pharma sector. Here are the ways of technologies and of transportation, technologies of transportation of CO2. Mostly we were referring to hydrogen in previous presentations. I would say that in Europe they have been using methane pipelines for hydrogen, but concurrently with that they construct pipelines for CO2. They obtain hydrogen at steam reforming. And so wind and solar energy will not provide huge volumes. They need big volumes, and so CO2 should be utilized. In one direction, it's hydrogen. Into the other one, CO2. It's all offshore injection for burial, for storage. Norway, France, and Germany are doing that. In Germany, they are lining pipeline with the CO2 from Germany to Norway offshore to inject CO2, and someplace in the Baltic Sea up north they get hydrogen. The existing technologies of storage, it's rock, aquifer, depleted methane, coal, formations, and we can say that the legislation is underway covering all of those things, and of course it's most desirable to develop such projects in Russian Federation on CCS and depositing of capture and storage of carbon. So we can develop those technologies as well. They're most needed. Thank you very much. Thank you very much. Next presentation, and then we'll have discussion. It will be by Mr. Dorohin Gazpromny Gas, PhD in engineering, hydrogen as a source of carbon dioxide, special aspects of carbon dioxide storage in geological formations. Lots of presentations were referring to different scientific surveys and studies, but I'll mention the methodological guidelines developed by Rosnedra organization. So now we should mention the fact that our ministry is amending the legislation, and now they're saying the placement or storage of CO2. CO2 is a commercial product. It could be ejected, then withdrawn and used. So at the legislative level, they made this remark, we don't say about dumping of hydrogen, we are saying about storage, and the issue of decarbonization nowadays has been subsiding slowly from the global agenda. But I should say that it's not the case, really. On October 26, 2023, no presidential decree was issued endorsing a new climatic agenda for Russian Federation, which makes it a point that we should combat high CO2 emissions. Correspondingly, our legislative frameworks have been extended by the year, and that all the volumes of large polluters would be identified. Let's say it's hydropower plant. It could be several dozen billion emissions into atmosphere. Even it's 10%. It's shattering statistics. There are other markets like methanol market, cement market, so we'll be able to have huge amount of those products, so that even if we try to tap different markets, we won't find it possible to sell all those huge volumes. Hydrogen in its own turn is by the same token the source of CO2. So it's necessary, and in Europe they do that. They have got such projects around. But there are no first-hand technical solutions yet. There will be a pipeline for CO2 and a pipeline for hydrogen, and correspondingly in the slide you can see the analysis of global experience on creation and operation of CO2 and hydrogen underground storages. A lot has been said about that as well. And here you can see schematically the way we obtain hydrogen from what and where CO2 is formed and how, and so it goes for geological burial depository or for enhancement of recovery. And there are so many installations on the grounds of different enterprises, so the companies can obtain hydrogen on their own account. Some use electrolyzers for that, and there are small volumes they produce on their own accounts for their own needs. In this slide, you can see the hydrogen produced from natural gas mostly, and it's common knowledge that it's done with the emissions of CO2. Pyrolysis has got its own downsides. It's hard, solid hydrocarbon. What should we do with that? If there are heaps and heaps of solid hydrocarbon, you won't be able to pump it underground. Where are you going to accumulate it? Because the accumulation of solid carbon in such amounts is underdeveloped, so it will be accumulating and build up, and there are some are referring to steam reforming, which would be a better solution versus pyrolysis. Even mindful of CCA, some of the overseas publications are maintaining that it's more lucrative and advantageous than pyrolysis. Here you can see a plethora of all those hydrogens: black, navy blue, green, white, turquoise, blue, and white, and so on. I would like to emphasize white hydrogen. There are some natural fields of that. From the practical standpoint, we can assume that there are sites which could store up to 30 or more percent of hydrogen. Everything is rather good altogether, provided something evolves. Mindful of such volumes, hydrogen would not be stored there in the first place, but we should study it from different angles, scrutinizing the situation. There are lots of publications about it. And there is also golden, purple, pink, red, and other colors, hydrogen, a broad palette of that. The Institute made a sequence of experiments, filtration experiments. It was proven in which aggregate state it's better to be stored for long-term storage, where we should displace buffer volumes to enhance oil recovery and fluid recovery. Gazprom Добыча Orenburg has been using it for EOR. They inject and they produce extra volumes of oil. And as to Gazprom Добыча Orenburg, they streamlined their own competences and first-hand experience along those lines. They can pump it, they can inject it. They are not fearful of handling it. Despite the fact that is the gas, it could be hazardous. And also we scrutinized the impact on the core metal and minerals of that gas, and there are some challenges that come along as to corrosion. Most are using static conditions, static state. We made a number of experiments, numerical experiments, based on Duardo model. If we are simulating a well with filtration of a fluid, with the presence of, let's say, 10% of CO2 and 90% of methane, then corrosion could increase 100-fold. So the Institute made this numerical experiment and verified it because this model is based on real data, plethora of data which was around. So correspondingly, we would like to verify this on the unit, which will enable us to create that velocity which would be acceptable for our bed conditions at UGS wells. And here are the conclusions. I will not read them out. Thank you very much for your attention. If you have any questions, I'll take them. Thank you. As the Institute representative, you did lots of theoretical work. Now you should shift to hands-on experience. I think it's high time for us to shift to pilot projects. And to implementation even, to be more ambitious, mindful of America, Europe, and so on, when it's at least one well, or some are doing that on 2 wells or 3 and 4 wells drilled like that. And they were making pumpings, and they do monitoring, and they report about very positive experience towards the center. So Gazprom Company Group is ready to practically implement this technology in big scopes and scales. Thank you. Very important and very insightful presentation. Next one will be about legal, academic, and technical support for CCUS projects around the world by Anton Sokolov. Colleagues, it's very challenging because I'm standing between you and coffee break, and I'll try to be very brief. Because we have discussed lots of things in the previous interventions as to pumping. This process is not altogether simple from the legal standpoint. On the average, the time from obtaining the license to the process of injection will be about 6 years, or it can take 4 years if we speed this up. Those of us who is deeply engaged in CCS and CCUS issues, these are different projects which are underway. Along those lines, that is the map of 2021. It's more than 100 projects like that. And which projects out of this made big stride forward from pitching the idea to commercialization and business cases? Just a handful of those. Mindful of the statistics of IEA, we can see that at the end of the day, the number of the projects which are at the stage of operations is not changing with time. It's slightly growing. So some projects are work in progress. Or some are at pre-commissioning stage, but there is a plethora of projects which are only on paper, so just only planned at the level of DFID only. As to the technologies and policies and politics and key challenges, they are around, they're hovering over us. It's not carved in stone, it's just my assumptions. From the standpoint of science, we're all fully aware of the basic principles of carbon capture. And it's common knowledge that we'll need new materials because it's not possible to use the existing pipeline systems. And there are examples of that, like in the USA, since the 1990s, they are constructing dedicated, designated CO2 pipelines, and those projects are thriving. From the standpoint of capture per se, there are some projects which require substantial financial interventions on behalf of the states or technologies of direct capture from the ambient air and so on. For those technologies to make big strides forward, maybe governmental interventions necessary and geological assessment of the reservoirs where we are planning to store CO2 is very important as well, because I am here to remind you that we are talking about periods of 1,000 between them. We'll have to store underground CO2 for thousands years, not just to inject them there. There could be secondary transformations in rocks. Alongside with that, assimilation capacity is limited yet. Technology-wise, there is a plethora of factors we should take on board. It's the horizon of assimilation, among other things. Or secondary jointing in the rocks. This sector is dependent strongly on oil and gas sector because it's one of the largest polluters emitting CO2 and one of the largest consumers of CO2. As to transportation, we have got well, like in USA, there are some systemic pipelines, but mindful of maritime offshore projects, they will require specialized, dedicated gas carrier vessels. From the perspective of political implications, one of the biggest challenges is cross-border system because nowadays, as you know, the projects on the dumping and storage are implemented by hubs or companies from several countries, and CO2 is accumulated from the issuers, from those who emit the CO2 into atmosphere from different countries, different sources. As to storage and offshore conditions, of course, maritime law is important. Maritime convention, maritime law convention, and maritime bed, and so on, that comes into play as well. Aside this, there are other challenges.
How shall we determine the plot for location? If you look at the geographical map of Russia or other country, we can see that the potential storage sites are plentiful. But if we use the criteria that the regulator give, there are some 30 criteria, then that shortens the list of the possible locations of the UGS. And the reason for that is the urbanization of the promising areas which might be lucrative for storage. And then there are nature protection zones. You cannot possibly store CO2 under these, and some other constraints from the point of view of the utilization of the natural resources. So another issue is the ownership and responsibility and liability. Who will be owning the CO2? If we look at the applicable law of the foreign countries, then it is the state that is owner. What about leakage? If there is a leakage or major incident, loss of containment, then this issue is not covered by the legislature. As far as value chain is concerned, it's clear. It is capture, transportation, and then injection into the UGS. I will not read out what's written over here, but let me remark on how well these things are studied. I will cover the issues of science, technology, and policy. So I've mentioned the problems of transportation and storage, and the policies are minimum over here. But the storage and transportation are well-known technologies, and I'd not refer to any particular country, but just the average, the general picture. It's just like the average temperature of the patients in a hospital. So, technology-wise, technological approaches, benchmarking of the technologies. I have shown some 100 projects, but right now there are some 250 plus projects. And 40 of them are operationals. The other projects are at a different level of readiness, concept studies, engineering, etc. And the projects are based on the established practices of the oil and gas industry relating to modeling, geological modeling, drilling, using CO2 for injection, for formation pressure control, etc. And it's not only about practical practices of the oil and gas. We are talking about other emitters. It is different power plants, units using gas. And, it is the units, the gas processing facilities, and we shouldn't forget about the infrastructure. There are existing pipeline system for transporting CO2, and there are pipeline systems that might be using for pumping CO2 now, but previously they were used for pumping natural gas. And it will be feasible to use the CO2 at brown fields. And it is still part of the oil and gas industry. Talking about the projects which are at the earliest stages of their development, that will be completed after the year of 2025. Half of these projects are related to oil and gas, but metallurgical sector and energy projects are the projects to capture CO2. But still, 50% are using CO2 for injecting it into the formations to displace oil or gas, or fluids, of hydrocarbons in general. So the projects that will be commissioned later at a longer horizon of time they're still linked to the oil and gas, and in this case, the CCS is a strategy for the coal mining industry and sustainable development for metallurgical industry using retrofitting technology, that is installing the equipment at the brownfields, and more focus is given to sustainable sources of energy, renewables, hydrogen, etc. Let's do the benchmarking of the approaches in different countries. So it looks strange, but had we have taken the other countries, they would fall into this quadrant. And the state undertakes to regulate this sector. Whether it's sustainable, I'm not sure. And now, when we talk about the subsurface storage technologies for the CO2, the state is interested in this, and some alliances are, and that's why they're engaged in these projects, introducing regulations. And they regulate both technological processes, trying to influence how deep the processes should be. But anyway, they do that either by enacting laws or introducing taxes. So CCUS is a long market. The initial capex are very high. The payback period is very long. The uncertainty is very high. That's why state support is needed, because otherwise the market will not be developing at the initial stage. It will not be kicked off. But I have mentioned that there are legislative barriers both in Russia and in the other countries, and those barriers on the path of the industry does not make it possible for expansion of the industry, because it's necessary to define what CO2 is actually for transportation. And even there is a difference in approaches in Russia and the CIS countries. There are international hubs for CCS, but they are functioning in the artificial legal regimes, and general approaches, harmonizations are needed, and there will be higher demand for harmonizations because there will be more projects like that. Summing up, science, short-term and long-term new materials are needed, forecasting and monitoring of how the CO2 will be behaving subsurface, and the infrastructure is of paramount importance. Because the multimodal transportation network for transportation of CO2 is needed. It should not be backed up by the oil and gas assets and the existing pipelines. It is necessary to develop a cross-border interaction and wider approaches, international cooperation. From the point of view of geology, it is necessary to ensure storage safety long-term. And the time period should exceed the lifespan of a human being or few generations. policy-wise.
Да, с точки зрения тех
talking about the decision makers, policy makers, it is necessary to develop the legislative framework and markets. I've been talking about the legislation and the bottlenecks that do exist.
Не позволяют CCUS индустрии развиваться.
Barriers for the development of CCUS, and from the point of view of the market, it is necessary
когда нет инфраструктуры, нет инвестиций, нет и поэтому необходима, конечно, поддержка международных хабов.
And the support of the international hubs is necessary. And the hubs might be interesting
углекислого газа, которые есть сейчас, в рынке более открыты. Ну, то же самое, что, собственно, с водородом. Да, рынок каптивный есть, но этот рынок, он никак, он там многократно превышает, конечно, необходимо ситуацию менять. Ну, и о чем я уже говорил, да, сокращать время для на этап эксплуатации. Средняя цифра, посмотрим там на США.
6 years is the average figure in the US and Europe. It is the same time needed from getting a license till the start of the injections. The key conclusions, the three takeaways
хотел бы, чтобы с вами осталось. Первое, да, это необходимо
First, cooperation,
снижать административные барьеры.
reducing administrative barriers,
Я не буду здесь подробно останавливаться. Тут пояснения есть, они, в принципе, повторяют то, что, о чем я уже говорил. Коллеги, кто захочет, если вдруг продолжить эту дискуссию в дальнейшем,
моя
рабочая почта, рабочий телефон, и сможем с вами... Внимание, я не буду тратить время сейчас на вопросы. В следующем докладчику.
I won't be taking any questions. The floor will be given to the next speaker.
Спасибо большое, Антон Николаевич. Вот, честное слово, любое другое впечатление от презентации, кроме, как вы сказали,
there might be no other
позволю себе с вами не согласиться. Вот тут у нас...
I would allow myself not to agree
to you.
When I have heard multimodular from some other speakers, and I think we do not allow something to the youngsters. But you have used the same word, multimodular, and I'm just wondering whether we are moving in the right direction. I can only say if different people from different organizations on different occasions repeat the same things, that it might be the truth. We might be right. So, unfortunately, we were on time with our first session. We are already behind the schedule. We cannot work without break. Let's have a 15-minute break, and we will continue with the Unit 3 after the break. Thank you.
Ага, включился, да?
Okay, the microphone is on. Let me invite the panelists. So,
В таком порядке.
in the following order.
Значит, Николая Николаевича Луговского, заместителя главного
Mr. Lugovsky,
отдела
the
подземного
deputy head engineer from Gazprom Transgas, Belarus. Yes, you can have your seat.
Костикова Сергея Леонидовича,
Then Mr. Sergei Kostikov.
заместителя начальника управления, начальника отдела ПАО «Газпром».
He is the
Только что как
deputy
Значит, доклад Александра Иосифовича, да?
from Gazprom.
Ермолаева. Вместо него будет Амшинов, да?
And we have Mr. Amshinov instead of Mr. Yermolaev
Рождение РГУ нефти и газа имени Губкина.
from Gubkin Institute.
Хайдина Мария Павловна находится у нас на совещании с ректором.
Haidina is
Захаров Денис
at some
Юрьевич.
other happening.
Проходите тоже.
Mr. Zakharov.
Фамилия вон там с краешку.
Yes, we have your name tag over there. Mr.
Контроля строительства.
Zakharov from the Gazprom UGS. He is senior expert of well arrangement and construction supervision.
Спасибо. И давайте
And I will be calling the speakers from the
презентации
hall.
Николая
Let
Николаевича.
us start with the presentation of Mr. Nikolai Lugovsky. And he
Технологии
is Deputy
обустройства,
Chief
системы
Engineer
скважин подземных
of
резервуаров, подземных
Gazprom
хранилищ газа,
Transgas.
каменной соли.
The
Пожалуйста.
subject matter is technology for equipment and operation of the well and underground tank system for the UGS.
Добрый день, уважаемые коллеги. Вашему вниманию представляется презентация.
Dear colleagues, I will be talking about the technology for equipment and operation of the well underground and tanker system in the rock salt in the UGS in Belarus. Why the need to develop the technology? In 2006, we were quite proactive to expand the capacity of the UGS system, and the state handed over the storage of the light petroleum products to us, and there were 8 subsurface caverns. The task was to develop the technology of refitting, re-equipment of these storage facilities for storing gas. We have studied the European experience of the conversion, and we deduced that it is necessary to develop a technology of our own to convert the underground storage for storing natural gas. So the gas transportation system and is indicated at the screen. And there was a lot of words mentioned about the importance of the UGS. We realize only too well that the UGS in the salt rock has got a number of advantages versus aquifers. It is a high peak productivity, and it is a good ratio of active and buffer gas and good integrity, containment of the gas storage, and the possibility to work in multi-cyclic technological regime. And right now, Gazprom Transgas Belarus operates three. One is Osipovitska and Pribukska in the aquifers, and Mazyrska in the rock salt. And the total operational reserve is 1.1 BCM, and with a lot of daily consumption. A few words on the geology of Mozyrsky UGS. The geology is favorable, and the UGS is located some 5 kilometers to the southwest of Mozyr, and it is part of the Mozyr salt structure. It is a pier that has been formed by salt tectonics. The salt body has low content of non-salt embedding. The depth is more than 2,000 meters. That's how much was tapped. And those conditions make it possible to have caverns up to 800,000 cubic meters. We started with 80,000, then 100,000, and these are the caverns that were handed over to us, and now we have a cavern with the capacity of 800,000 cubic meters. That's the cross-section of the geology. The depth of the top of the salt formation is some 600 meters, and the depth of the body itself is 2,000 meters, as I have mentioned already. Talking about the technology, after the construction of the cavern, there are highly hermetized casing introduced. It is 245 millimeters. Then there is a lift column that is composed of the following elements. It is the valve shutter, hydraulically operated, to close the cross-section of the lifting column if there is a loss of containment. Then it is a thermal compensator to compensate to offset the elongation of the column if this is happening.
There is a perforated by a pipe. There is circulational orifice or perforation part of nipple is in closed position, and it's also connected to an anchor. We have made a video trailer. So this is important for brine displacement. The nipple, when it's closed, is an upper portion or near the operational riser. Inside the column, there is hydraulic pucker. Above the pucker, at the distance of several dozen meters, there is thermal compensator. At wellhead, at the depth of 1 or 2 meters, there is shutdown valve. Natural gas is fed to the well and is displacing the brine over the orifice above the anchor. After displacement of the border of gas brine into tubular space, natural gas is fed, and injection of gas into annulus place is shut down when there are leakages. At the next stage, brine is pumped, injected, and there is excess pressure. When it's above 12 megapascal, Parker is set to operation. When the pressure is increasing, then the circulation windows are opening up, and the lower closure opening is closed. So now this system of underground reservoir is ready, and subsequent injection and pumping is done via upper orifice of the nipple. In this slide, you can see the general information about Mosul UGS. The commencement of the construction is 2006. First injection was made in 2008. First withdrawal in the season of 2009-2010. Currently, the active volume of natural gas is 350 MCM, and in line with confirmed with Gazprom plans, we envisage further development of Mosul UGS to active volume of 868 MCM. Here are the major advantages of the technology applied. As I have mentioned, studying overseas experience, we were fully aware that in order to do the primary displacement, we should apply other services with specific dedicated equipment, so that there is a displacement of brine and its recovery using specialized gateway equipment. The technology taken on board in Gazprom Transgas Belarusia enabled us to do the full import substitution. All the equipment applied is manufactured in EU countries. There are big batchments of that, and there could be terms of reference, so it could be done in a more customized way. The technology was technically tested. It has proven to be safe and robust and very efficient. Technology-wise, we can say that it's possible to segregate and insulate over the casing space. And there are anchors, and there is shutdown valve to enhance safety in case of the loss of the sealing of the equipment and airtightness of it. There were several publications on this work also in Gas Industry Journal, in the Scientific Journal. There were 2 patents for invention in Belarus, and Russian Federation issued. And this work and this technology in 2012 has received the award of Gazprom company. As to economic effect, we calculated that with the help of independent appraiser from the Research Institute in Gas Economy. So there is a reduction of capex. The averaged cost of the technology retrofitting the way we did in Belarus is 30 million. And 142 million is the cost of the technology when we use the services of specialized technological organizations of European companies. Here you can see the economic effect benchmarks. The average data on capex saving on one well is 112 million Russian rubles on 15 wells. In prices of 2021, the capex was reduced by 1.6 billion Russian rubles. The indicator of integral economic efficiency is more than 1 billion Russian rubles. This technology is very relevant for Gazprom company. We are fully aware that this technology of retrofitting and primary filling of those underground reservoirs of rock salt could be implemented at most of UGS. It's very straightforward in implementation, and at the same time it has proven to be very robust. I'm here to say that the implementation of state-of-the-art, best available technologies based on domestic resources of our states is especially important amid the current situation of sanctions pressure. Thank you. That's it.
Спасибо большое, Николай.
Thank you very much, Nikolai.
Все это важно для нас, действительно.
It's really, truly important for us, your experience in Belarus on operating salt rock underground gas storages. We are doing similar work, and we're hopeful that in future we'll also be cooperating most successfully. I don't hold you up if you need to go. Thank you. Then, Sergey, are you going to give us a hand with updated program?
Значит, тогда пригласили мы
invite Sergey Kostikov, deputy head of the division of Gazprom, with a presentation of influence of interferences of injection wells upon area distribution of gas saturated and water filled and water flooded wells. Thank you, colleagues, ladies and gentlemen. Notwithstanding the difficult title of the presentation, it's all about very straightforward things, and as we're tight on the agenda, I'll try to be brief. I would like to introduce the authors who are not present here, because before me, Marat Karimov wanted to have the presentation. He couldn't make it here. He is a senior researcher of Gubkin University, and also Ms. Maudalieva is a senior researcher of Gubkin University as well. This presentation will be of more interest for the specialists working in geology and development of the fields and operation of UGS, and I'll explain why. Aside the fact that it was mentioned that our Chinese friends are very successful with all the technologies. They create UGS in depleted hydrocarbon fields and in rocks. As to aquifers, there are some problems in creation of that. We don't have experience enough along those lines. The technology is yet rather inferior towards this end. A while ago, when we were constructing one of the UGS in central region of Russian Federation at the outset of 2000, we have encountered the situation when aquifer formations which we contemplate to create UGS, they are detached, and they are multi-layers in thickness, irregularity in area, complex lithology. So when we try to create UGS in those aquifers, we encounter some problems which are characterized by rapid development of unstable movement of gas-water contact and entail low values of gas saturation and active gas volume. We always contemplated those things. Let's say we have injected into the storage good formation pressure is there, good volumes of gas. But when we start withdrawing in some of the production wells, there are issues related to water flooding, and they are stalled for several days after we start withdrawing gas. So it's high water factor, so the wells are stalled for several days. Maybe it's downtime, which is bad altogether because it reduces the coefficient of use and operation of the stock of those wells and reduces the UGS potential altogether. So we used to have different geophysical methods of studies back then, and now to control gas saturation at the borehole of the wells. Unfortunately, they don't have high resolution along the radial direction, especially in the wells with extended borehole. When we have spot bases there, we cannot explicitly identify the degree of gas saturation, which entails the situation so that at the end of the day, this area has been accumulating. And there are some hydrodynamic geological models and so on, and the area has been accumulating when we are not clear about the exact volume of gas saturation. So subsequently, those areas could backlog. And a while ago, and that is one of the federal requirements. A while ago, there was the storage in aquifers, so we had to do geophysical studies to be unbiased and monitoring for sealing, tightness, and so on. We had different studies conducted in production wells, and after the end of injection gas saturation in the wells, we studied those wells which were flooded for withdrawal, for the beginning of the withdrawal. Gas saturation mounted up to very high volumes, 80-85%. That means that those wells, after completion of the injection, were operating in a good way. We used different GIS methods for gas saturation assessment. It was industrial volumes, very high volumes, that is, and we thought that everything would be all right. Then there was withdrawal, and the wells were flooded, and then they were stalled, and it was idle time for several days. On top of that, our geophysical methods, our current methods, are rather inferior because on the results of GIS, we cannot make a statement about gas bubble in gas-saturated aquifer, its geometry and distribution of gas saturation along the formation. So there is an error margin which is rather high, which is not good altogether, because on top of everything else, on the basis of geophysical studies, we construct different regime maps, and we also may trust the robustness, because that is about the assessment of efficiency, productivity, and accumulated volumes. So we need more precision on those studies. I slightly digress from the main line of my presentation. It's common knowledge that about 80% of information is obtained by humans visually. That way, humans could make adequate assumption about the ongoing natural processes and create more sophisticated mechanisms of the observed phenomenon, which is very important for the development of technology of process control. In this slide, This, you can see the outcome of the applications of our systems and modeling. We had to do something with water flooding of the wells in aquifers. On the one hand, you can see displacement of formation water by natural gas. And displacement coefficient is 0.11, 0.14 units. On the right-hand side, it's homogeneous filling by gas after the application of surfactants and gas saturation. The displacement factor is 67-75%. Here at the wells of Vazovsk, UGS successful surfactant treatment increases well productivity and recovery by 30-fold. And efficiency and successful physical chemical treatments achieved 63% increase. This effect of water cuts should be perceived by us in more detail. We wanted to figure out what it was all about, so we outreached our sectoral university, which takes the lead on all those studies, Gubkin University, under a theoretical basis of distribution of gas saturation and microstorage around each production injection well after formation of artificial placer is shown here. Micro irregularity in the formation on benchmarked and theoretically established points is shown in the following way. As to the borehole of the well, it's RC index. So the transparent model shows curve number 1. Gas saturation along the front-end experiment is between 11 and 13%. Calculated by Barclay-Leverett approach is 24%. This is curve 2, and curve 3 is quality curve or probability curve along several experimental points. We have tried to visualize on computer the interference of the injection wells. Out of those 3 wells we selected, we started injecting very proactively in well number 2. And as the chart flow shows, as the volume of the gas is increasing, the gas saturation is approaching the neighboring wells, well number 1 and number 3. Then we carried through with our simulation. Here you can see 4 wells. So is the grid of 4 micro storage wells. Injection starts simultaneously in those wells by the same rate, same volumes. The volumes are identified, their total volumes, that is. And you can see that the contour of gas saturation at the outset of injection is symmetrical toward the central, from the center of the wells. Then this contour starts shifting from the center of the wells after injection with increased volumes, several-fold increased volumes. This asymmetry has been scaling up, and it shifts outside from within, from the center of the wells towards the edges. And you can see this asymmetry with the volumes, increased volumes of gas, how it is displayed. So there will be final volumes of injection shown here.
And this slide is an explanation of the zones, stagnant zones are shown in yellow, and it has a water cut And then we answered the question. We have just started the well, but why the water high is so very high cut? And you can see that the water volume when the well is started, because the gas saturated part is asymmetrical with respect to the center. The gas is moving to the side, and the water is pretty close to the center. And then some of the wells have a very high porosity and permeability, and with high depression, the water is flooded and it is not operable anymore. It starts producing. Here is another interesting picture, and the number of the wells here is 16. The blue shows the gas saturation of 50%, gray is 30%, and white is lower than 20%. And this slide shows the splitting of the gas saturation when the water is there, and it is a premature increase of the water cut. Premature flooding. So how can we avoid that kind of phenomenon when constructing the UGS? Getting back to the model of 4 wells, and initially there is a certain water gas contact, and initially we start injection with 1 well, low rate, low volume. And the other wells are drilled, perforated, or they have a long bottom area, but there is no injection going into them. 1 well is only used for injection. With pumping a certain amount of gas, the gas saturation is growing, and you can see it is symmetrical versus the axis of the center of the well. And in this case, we have the movement of the gradient of the pressure gradient. Then the volume of the injected gas is growing, and the gas saturation affects and crosses the wells with no gas injected. We inject into 3, and well 1 is already gas situation, and and the well 4 as well. And at that, the front is approaching to the last one, and as a result, the wells that do not have any injections are still gas saturated, and at that there is no rupture, there is no break or gaps in the gas saturation that was shown at slide 9. So the so-called inter-well volume. Over here, we have a high-quality gas-saturated volume, and well, there's no symmetry. There is an asymmetry, but at the same time, with higher volume, the gas saturation is being leveled. We do not have any gas saturation splitting, and in the future, if we will be using 16 wells, and if we make use the same technology of creating the equal gas saturation field, we will be able to operate the UGS with the minimum water cut And of course, we cannot do without the information water, but its behavior will be predictable, and the UGS will have a high productivity ratio. I would like to mention that computer visualization made it possible for us to explain the square distribution of the gas saturation. Besides, we have developed a new technology for development of the UGS. We have patented it. The patent holder is Gazprom. And there are priority facilities for this technology, and we know which these are. It is essentially the UGS that will be created in the aquifers. And this technology is efficient at the green fields, and when the new areas are included to the existing fields where the well clusters are drilled, and where it is possible to create micro storage, G storages. I would like to note that we didn't find any reference to that type of works in either Russia or abroad, and besides we received a patent in China, WEPO. It's the international IPR. Thank you. If you have any questions, I'll be happy to answer them. I'm for the second. I'm over here at the forum for the second day, and sometimes they approach me and ask, are there any questions for your presentation? No questions, everything is clear. If there are any questions, it's only about the name of the title. Thank you, everything is clear and true, if I understand it right. This work was started.
Помните, что такое ФЗ?
You might remember the abbreviation of two Russian letters when there was an urgent need for something at the time of the war, and then the problem was solved, and we engaged Gubkin to address this urgent need, and so the task was fulfilled. Next talk is Mr. Abshinov from Gubkin on modeling of USG operation procedures for low permeability reservoirs.
Да, это презентация Ермолаева.
Yes, that's the presentation of Alexander Yermolayev.
Сейчас.
Just hold on. They have it.
Отлично.
Perfect.
Добрый день, уважаемые участники
Good
конференции.
afternoon, dear participants.
Основные результаты исследований.
Allow me to present the results of the research done at the gas and the gas condensate fields
Основной акцент в работе сделан
department
на
of the
исследовании
Gubkin
влияния
University.
параметров
So the natural and the technical parameters on the operations
коллектором с низкой
of
проницаемостью.
the
Поставленная цель
UGS of low permeability.
решением следующих задач.
The following tasks have been resolved to assess the porosity and permeability on the indicators of the operation of the UGS, assessment of the efficiency of different solutions,
объекта от числа размещения скважин и их
the
конструкции.
determination of the dependence of the operating indicators on the numbers and layout of the wells. So the data of the synthetic underground gas models are shown over here. The initial reservoir pressure is 128. The depth is slightly higher than 1210, and the
За пределами купольной части 100 метров.
cell size in the dome part was 50, and outside of dome is 100, and cell size in along z-axis is 1 meter. I would like to note that porosity and permeability vary, and we studied the fractured and porous formation, and the formation is a combination of the porous media as a matrix and fractures, and the following parameters have been studied: the porosity of the matrix, its porosity, and the porosity and permeability of the fractures. The permeability of the matrix and porosity of the fractures did not affect the operation of the UGS. The major impact is exercised by the porosity of the matrix and permeability of fractures. The dependencies are shown over here, and we can see that the bottom hole pressure increases when the matrix porosity decreases, and when the porosity of the matrix is higher, the water flow rate increases, and there is watering of the well durings. So both high and low porosity values can have negative impact on the process of creation and operation of the UGS. The porosity of the fractures has the following effects. The higher the permeability of the fractures, the lower the depression of the bottom hole pressure, but at the same time the produced water volume is higher. To measure the porosity of the matrix and permeability of the matrix and its effects on the formation pressure, we built the diagrams which show and make it possible to make judgments. What are the areas of the most favorable conditions for porosity and permeability for the development of the UGS and such media? The diagram shows the lines of the radii of flowing to the left, and the diagram to the right has the bottom hole pressure versus matrix porosity and fracture permeability. Each line corresponds to the specific parameter. And one can see that to get the lowest spread of the gas, the high porosity of matrix is needed, and the permeability of the fractures. It is blue zone, and pressure is affected by the matrix porosity, and the permeability of the fracture is not a factor. The first technological solution of the work is using horizontal wells. We studied different combination of vertical and horizontal wells. 3 options were chosen. In one, all the wells are vertical, variant 2 horizontal, and then the number of fracture of the wells of different type fluctuates. The calculation shows that 2 horizontal wells reduce greatly the flow rate of wells and due to lower depression. Another technical solution, another option is using fracture and using fracking the formation. The bottom hole pressure is lower during injection, and it was higher during gas extraction, thus accordingly lowering the values of depression and repression. However, the negative effects were there because if fracking was used, we had more produced water because the water permeability was higher. We have undertaken to identify the favorable ranges of porosity and permeability, and we use the diagrams of applicability of fracking based on the porosity of matrix and permeability of fractures, both when using fracking and without it. The favorable range corresponds to red areas, the highest productivity actions, and it is possible to increase the productivity of the areas. I would like to note that when the porosity and permeability are higher, we can see that at figure to the right, the values of productivity go down. That means a lower efficiency of fracking operations. Similarly, we evaluated productivity efficiency on the ratio of useful gas to buffer gas. The mode of operation was the same. However, the higher the number of the producers of the wells, the ratio of the gas to buffer zone is growing. If the number of wells is more than 8, then the growth of the ratio is going down. And that when the number of the wells is higher, more water is produced, and with the simultaneous operation of 6 and more wells, the growth of produced water is more intensive. To conclude, I would like to note the following findings. The greatest influence on the creation of the compact gas saturated volume and the bottom hole pressure and the production of water is exerted by porosity of matrix and permeability of the fractures in the fractured reservoir. The most favorable range of the porosity and permeability are high porosity and permeability of fractures. The use of horizontal wells makes it possible to operate wells, no water produced, and lower depression. And there is a certain number of wells, and in our case it was 8 and more wells, and the growth of active gas to buffer gas ratio is going down. That's it. Ready to answer questions if any.
Спасибо.
Thank you.
Я бы хотел бы дать слово нашим.
I would like to give the floor to our guests
А вот есть Луговский Николай Николаевич?
It,
Как раз тут просто...
So Nikolai Lugovsky had his presentation already. So we are going in the reversed order of the presentations on the agenda. Nikita, maybe our Chinese colleagues will be able to speak now.
Марья Павловна.
Хай. Надо помочь с презентацией. Что-то случилось? Тогда и вновь Марья Павловна, это очередная тема.
This is the carryover from the last year. There are problems of water cuts of the wells and large flow rates on water in large gas-saturated zones. To reduce water factor, we should do certain efforts. So it's very important, and I'll be rather brief. So I'll just tell you that I'm going to do the stock taking of the real implementation of the methodology for reduction of those hazardous factors. You have seen this graph last year at the last forum, and here you can see that the upper one shows 1 year, bottom one, 2 other years, and concurrently 2 different sites. Simulation in practice shows the sprawling out this gas-saturated zone. At the age effects, we can see that the gas saturation value is very low, but gradually those zones would be gas-saturated, and gas saturation within 10 years, it's not a lot for us, but nonetheless, there will be gas proliferation at the notch of 0.6, 0.7 at the orange level. And this is like a chessboard that shows going left to right. It shows 2 different years on months. Month 1, month 2, month 3, month 4 of drawdown, of withdrawals, the way the flooding is done. Water cuts done in 1 year on 1 wells, and water cuts and flooding are done on other wells in a different year, because the withdrawal and injection are identified by geologists when they get special volumes and scope of work to do. They decide which wells they are going to use in this process. It's very infrequently when they discuss it with outside specialists. The calculations they do on those balance simulations would not tell us a lot. Yes, certain volumes should be injected, but where exactly? They don't say anything about it because that's the condition of balance model. This is the methodology which looks very straightforward and very instructive, but at the same time, it was tested just like that. And now I'll tell you about the results. Here you can see only descriptions, verbal descriptions, no specific figures, specific methodologies, just described just like that, verbally. And here are the deliverables of all that. So, our board commissioned us to do the calculations, and we use this methodology in one of UGS. We have been using them for the third season. That is the season of withdrawal, injection, and withdrawal. So, this is the hydrodynamic model, which is around there for the third year without any adjustments and amendments. It's the same. So we had to be in line with the methodology we should have done the adjustments mindful of sedimentations. We're strictly against stochastic models at UGS. We used lithological information. We used the core materials we had so that we had to figure out different rocks, which rock will provide us with which capacities and rate of injections and withdrawal, because hydrodynamic studies are not very precise sometimes for us to work when we have hands-on experience of using those underground sites in practice. Those wells were prepared. What we didn't do workovers in this site. We just figured out which of those wells are working at the level which is inferior to what we need. That the injection of those wells entails sprawling of gas saturation and excess water flooding, so those indicators were rather low, like injections were low, withdrawals were low, not to destroy the continuity of gas bubble which is formed there. I'm here to say that this is one of the edge parts of one of the flooded storages. It evolved because of the sprawling around of gas bubble. It hadn't been planned before for gas saturation. It so happened gas saturation evolved, and at the moment when that part of UGS was commissioned as active volume area, gas saturated zone was quite notionally identified, and water cuts resembled cocktail glasses with just straws in them. It was about geological permeability and impermeability. So we reduced the volume of produced water by 1,000 cubic meters from 37 to 15 liters. Last year we were active with injection. There was a big gas bubble, and we had gas ingress on the border water, and on the border the saturation was 0.7. Nowadays we went through withdrawal regime even before we intervened into injection regime. Now, after the injection, it's crystal clear that partially visualized part of this model entailed gas saturation reduction from 0.7 to 0.5. I'll show you the details in the next slide, but now I can see that we only partially implemented this plan of injection, because it's not always when we agree with the volumes we are suggested to inject to this site. It's located on the slope, and gravity and gravitation prompts us other volumes. It's the wing. Maybe it does need those volumes. Maybe we should return to the initial gas saturation of this site. We work without adjustments and adaptations and amendments. This is the model. That's the convergence between model and reality. And this is that case I referred to. Last year it was 0.4, 0.7 gas saturation. It's in this sequence because 0.4 was above and 0.7 was below on the results of geophysical studies of this observation well, which contradicts the physics law, because these are related formations. You can see it by logging. The drop in permeability is not playing a big role. There is impermeable interlayer which provides for impermeability along the vertical. So this saturation in the previous year was due to high rate of injection. This year we have got a normal value. It's not 0.7, it's 0.55, and it's above. It's rather complex situation above. Good filtration properties of this interlayer are displayed. It's a good saturation. Our purpose was to contain this proliferation of gas saturation, to reduce withdrawal of water so that this UGS could avoid sanctions from Rospotrebnadzor for very high levels of injection. Now there is automatic control over the injection levels. So Rospotrebnadzor has been scrutinizing us every step of the way. And the third part, what we observe is that we consider that we should raise the issue about the necessity of proliferation of UGS towards this, because this is the geological border we reached. Then we plan to assess the economic effect. If we stop producing excess water, we didn't do such a feasibility study at our UGS. And secondly, we'll have to figure out which should be buffer gas volume, which was sort of sprawling around a very big area before. That's about Rapsetamp. Thank you. Thank you.
Так, все-таки, значит, слово представляется.
The floor goes to Madam Mao Yanyan, Chief Engineer of Oil and Gas Department of Chinese Geological Department. She'll speak about current state of affairs and needs for UGS in China.
Загрузили?
Next, okay. Let me say good afternoon, ladies and gentlemen. My name is Bai Yan. I came from Oil and Gas Survey, China Geological Survey. My topic is the status and construction demand of UGS in China. Please allow me to introduce my work unit first. China Geological Survey is a public institution at the deputy ministerial level, directly under the Ministry of Natural Resources of China. It is a geological survey, scientific research, and information service institution. China Geological Survey is responsible for uniformly developing, deploying, and organizing the implementation of national, basic, Commonwealth, and strategic geological and mineral explorations. China Geological Survey fully supports the security of energy, minerals, water, and other strategic resources, and serve the ecological civilization popularizations and the national resource management. Okay, let's get to the topic. My speech will conclude the following four experts: why we need to construct the UGS, and the status in China, as well as the construction demand and the technical challenges in aquifer UGS in China. You know, China's energy endowment structure has the characteristics of rich coal, poor oil, and little gas. The consumption structure has long been dominated by coal, and the supply of oil and gas is insufficient. The total energy consumption continues to grow at a high level. In 2021, China's total energy consumption reached 5.24 billion tons of standard coal, a year-on-year increase of 12.5%. In that year, the gas consumption was 337 billion cubic meters, and the net import was 159.4 billion cubic meters, with an external dependence rate of 33.4%. The significance of gas reserves in balancing supply and demand is constantly highlighted. As we all know, on September 22nd, 2020, during the general debate of the 75th United Nations General Assembly, our president announced that China aims to peak the carbon emissions by 2030 and strive to achieve carbon neutrality by 2060. But there is a huge gap in gas production under the dual carbon target. It is predicted that when carbon emission reaches its peak in 2030, the gas consumption will be about 620 billion cubic meters, and the net import will be about 300 billion cubic meters. So accelerating UGS construction and enhanced gas reserve capacity is of great practical significance for elevating the pressure on China's energy resource. The UGS construction in China started late. The first UGS was
строительство ПХГ началось в Китае довольно-таки поздно. Первое ПХГ было построено в истощенных резервуарах в 1975 году. К концу 2020 года было построено 32 ПХГ. Общий
16.4 billion cubic meters, accounting for 4.5% of the total consumption. That is far below the international level of 12 to 15%. For the types of the UGS, there are 24 UGS in depleted oil and gas fields, and 18 UGS in salt caverns, mainly distributed in Bohai Rim, southeast, southwest, northwest, and Midwest China. But the main gas consumption area, such as the Yangtze River Delta and central South China, are short of oil and gas. There is a lack of suitable depleted gas fields for UGS construction. The working gas volume of the existing UGS cannot meet the gas demand. According to foreign experience, aquifer UGS are mainly constructed in and around the large industrial cities, so it is urgent to construct aquifer UGS to elevate the pressure of gas consumption in those areas. The oil, gas, and groundwater surveys conducted by my work unit, China Geological Survey, have found that the Yangtze River Delta and the central South China are rich in water-bearing traps and have the basic geological conditions for aquifer UGS. And the oil companies of China have carried out a lot of PRN works in the feasibility, location evaluation, engineering, technology, and other aspects of aquifer UGS construction in the central and the eastern China. Those works have laid a good foundation. Based on the analysis of construction condition of foreign aquifer UGS and the geological characteristics of China, the location evaluation criteria and methods of aquifer UGS construction have been explored. According to this criteria, some geological evaluation work of aquifer traps have been carried out in the central and the eastern China. But we still face many technical difficulties and challenges. We have concluded the characteristics of foreign aquifer UGS. They are simple structure, good sealing, good reservoirs with high porosity and high permeability. But the geological characteristic of in China, they are complex structure, well-developed faults, full reservoir properties, and the complex gas-water relationships. So the first difficulty is that the geological conditions for constructing aquifer UGS are poor, making it very difficult to select and evaluate the locations. And the second difficulty is that there is currently no successful precedent for aquifer UGS in China. So the key construction technologies need to be further addressed, such as dynamic sealing evaluation, production and injection optimization, pipe-stream structures in well completion, and so on. And the third difficulty is that the construction and operational management system for aquifer UGS is still in the exploration stage in China. The complex geological structure, insufficient construction experience, inadequate technology, and imperfect technological standard systems have brought a series of challenges. To address these challenges, we need to carry out the following 4 technologies. The first one, how to choose and evaluate the locations of aquifer UGS in complex structural areas in China, such as what are the principles, conditions, and evaluation parameters for site selection, and how to evaluate gas injection and production capacity, and determine the upper and lower pressure of the UGS. The second one is how to evaluate the geological sealing of aquifer traps, such as how to evaluate the static and dynamic sealing performance of cap rocks and faults, how to predict and evaluate the water migration and the lateral sealing when injecting gas. And the third one, how to evaluate the mechanical integrity of aquifer traps. What are the potential sealing damages caused by frequent changes in high and low pressure during injection production process? And the fourth one, how to predict and control the safety of the aquifer UGS? What are the safety monitoring index and methods for aquifer UGS? And what are the safety early warning standards? Now, we plan to carry out the location site selection work for aquifer UGS in Central and Eastern China. Gazprom has rich experience in aquifer UGS construction. Hope we can strengthen communication in the future. Okay, that's all. Thank you.
Okay, thank you. Well, excuse me. Okay. Да. Maybe I missed one point. And how many working volume do you need in aquifer? How much? How many working volume in aquifer?
In China?
Yes, in China, yes. You need.
You know, there is a huge gap in the consumption and the production.
Huge gap. How much? Huge. 10 billion?
Yeah, maybe.
20 billion? 50 billion?
Yeah.
Нет, ну, она сказала, большой гап есть между продукцией. Сколько надо ПХГ? Because your presentation was status and construction demand of UGS. What's the demand?
Demand is we need to construct aquifer UGS.
How much?
In
16% from internal consumption.
Yeah, perfect answer.
Okay. А какое внутреннее потребление?
16% from the internal consumption. Was it 16 BCM? It was 16 BCM, yes. And 300 BCM was imported. These were the figures.
Near 300 billion cubic meters of gas, internal consumption in China now. Now, yes? Near
it's
300 billion.
Sorry, I don't know the exact number.
Значит, ну, давайте возьмем 300. 16%.
Okay, let's take 300 BCM and 16% is some 50. So you need 50 BCM. That's the capacity you need.
For China, and so Gazprom, as you said, had very big experience.
With complicated mathematical calculations, now we have conclusion. You need near 50 billion cubic meters of storage capacity.
At least. At least more. At least more.
Currently you have 16.
Yeah.
16, but you need three times more.
Yeah.
Yeah.
3 times more.
And as far as I understood, the main region is east, southeast of China, where there is no possibility to construct storages in salt and in depleted gas oil fields, so only aquifers.
Yes, exactly.
But geology is very complex, and so Gazprom very experienced in the construction of aquifers, storage in aquifers, so we were open for collaboration.
Thank you. Okay.
Welcome, обращайтесь. Okay, great, thank you very much.
Well, colleagues, there are some other talks, and I would like to request you to be short. The next speaker is Mr. Zakharov. Will you start with the conclusions right away?
Потом Демид Юрий Алексеевич расскажете, как все-таки надо выбирать.
Then, Yuri, will you tell us how we are supposed to choose the locations, but very briefly, if you please, as well. Good afternoon, colleagues. I have been theorizing about the issues last year and today. I would like to talk how these things are implemented in practice. Initially, by way of introduction, we are doing the work over, and we use the subsidiaries to do the work over. And it is the workover of the wells at the UGS. So what are the processes included into the workover? It's not only the work on the wells, but organization of the work, dispatching, work safety, and emergency response. And the amount of these elements includes the machine interface, human-machine interface that defined all the successful operation of all this system. Safety of the workover process is subdivided into three processes. One is related to personnel readiness, another reliability of technical means, and three, it is the interaction between humans and machines. Talking about personnel, if any of you were present at last year's presentation, we have developed the techniques to determine the readiness of the personnel to respond to emergencies depending on their psychological and functional status. We have received the results of this study performed for the personnel of the workover teams. One is related to comfort, the response time, and correctness of the performance of the tasks, and it is dependence of the comfort of the members of the team. And we received the models for all the parameters. So what things have changed since? So we performed the in situ monitoring when the teams have been performing, and we could measure the time and the correctness of the performance, and to compare the actual results with the theory. You can see that the match is quite good. The only thing that in real time, in practice, the teams used a bit more time because well, it is obvious, but in practice, they performed the work correctly and properly. We received the results for all the parameters, and the practical results received were shown for all the parameters, and they are much better than the average results statistically. The red line is the theoretical models, and the practical results correlate well with the theoretical one. And we have the coefficient for the gap for our theoretical research to be more correct, to be more compatible with the practical results. Topic 2, it is the technical re-equipment of the process, and we performed a study regarding the equipment of the workover with using new equipment, and new equipment doesn't only work more reliably, but it is comfortable and convenient for the personnel. On the whole, there is a 40% increase in efficiency. The teams who use new equipment work more efficient by 40% versus those that use obsolete equipment. Before purchasing new equipment, we tested the new units, and that's why we procured more ergonometric equipment for the teams. Besides, the branches of the company have the system of key performance indicators. There are key performance indicators related to safety, and I have a breakdown of this key performance indicator for years. It is not very illustrative because we use the number of the incidents for 10 years, but there are no accidents. It is virtually none, zero, and so we cannot use the key performance indicator of what the situation at the branches is, whether they are ready for emergencies or not. But we can use our methods, our techniques, and we can test our personnel and see how they are coping. And every member of the team is measured, and whether their performance is higher than the medium value or lower. And based on that, we can develop a new values of this safety key performance indicator, and which will give us an understanding whether the team is ready to respond to emergency or not. So how are we planning to implement these methods? We have special benches. The slide shows the benches that could be used for monitoring the personnel, and the bench simulates. It is capable of simulating emergency situation when using coil tubing unit. And there is no well at that. The bench is installed, the coil tubing unit is used, the coil tube is installed into the bench, and we can simulate the emergencies and to measure how the personnel is coping with these. Another area is the system of monitoring and communication, and I would like to note that we are getting back to the question, what is more efficient when the decision-making is individual or collective, whether it is teamwork or individual, that is more important. And last year we have been talking the teamwork with emphasizing the role of the leader is the most efficient thing, but at the same time it is the primary the things, because the management personnel will have to kick in to address the situation. And that's why it will be necessary to develop the communication system, monitoring system, and visual observation system. Two factors that prevent implementing it.
Не везде у нас присутствует качественная связь для передачи сигнала. И второе – это то, что любая передача…
Secondly, any transmission of Any transmission of video signal is related to personal data, so is the personal data, and legislation-wise, there are very stringent conditions for processing and use of personal data. The legislative level, of course, they should come up with more explanations to remove some of the barriers. I will not read out all the bullet points in the slide, but I am here to say that the current systems from the standpoint of robustness and reliability, machine system connection, we should digress from competence and quality basis approach, not digress from them, but to use not only competence-based approach alone to identify professional characteristics of humans, but also how human beings can apply them in different situations. Employees can have knowledge, but not knowing how to apply them in situations which might evolve, and they should do it quite efficiently. We teach them to do that. Thank you. It's gratifying to hear that Gazprom UGS is very scientific about safety issues. Next presentation by Mr. Demidov. But please don't take too long for your presentation. I'm here to say that Gazprom emphasizes the importance of labor safety, and they are very stringent about it, so it's very gratifying for me to say that they have got a very good, insightful, and creative and scientific-based approach to that. Yes, and I would like to add to that we are doing that on our own account, and we're also supported by our colleagues from the Polytech University and Ukhta State Technical University as well. We do it by joint efforts. Well done. Thank you. So, dear colleagues, I would like to fill you in on the prospects for the creation of UGS. The track record of UGS in Russia is around for more than 60 years. And our industry had been through the creation of the first UGS in aquifers to peak storages in salt caverns. Since 2014, we can identify the active phase commencement for prospecting of the operating UGS and search for new ones in Siberia and the Far East. The robustness of gas supplies, as has been mentioned repeatedly, mindful of the very long network of pipelines and irregular consumption inside of the country. So there are lots of UGS in European part of Russia. As to the development of fields in the Far East and Siberia, there are the systems of reserving of the gas, inclusive of gas storages, to align irregularity in consumption and to streamline supplies to Asian and Pacific region. So 6 of those UGS are in the Far East and Siberia. 5 sites out of those 6 are studying traps and aquifers, and 1 site in salt rocks. There is a specificity for those traps, which is different when it comes to hydrocarbon stockpiles as well. Different stages in geological surveys of subsoil is regulated by law and different documents. It includes pre-investment, prospecting, industrial prototype stage, and commissioning. we do those stages in order to have the optimal sequences in different works and assessment of their results on the basis of interpretation of the primary geological exploration information. At each stage, there should be a comprehensive set of different works to deal with main geological tasks, and we mitigate costs for that. That way, if we study subsoil in a good way, we could do good design, creation, and safe operations of the would-be UGS. Geological prospecting is based on digital solutions, which are very different from those which were used in practice 20 or 30 years ago, and also streamline proven methods and hardware. As to the exploration background in the past, since 1960s, 1975, we can see that under small density of prospecting and geophysical studies, more than 100 different wells were drilled in that period of time. So prospecting and exploration was done by deep drilling. Now we do seismic exploration works before, and mindful of the small depth of occurrence, classical methodologies of seismic exploration should be adjusted so that we can find traps for UGS in order to map those sites interesting and proper to be used as a trap for UGS. They have got high density and high cost as well. So nowadays, we broadly use the methods of complexing and mixing of different methods. And we use different options and modifications of seismic exploration works. During exploration, we use broad azimuth and high depth of electrical prospecting. We mix those methodologies to have more precise data and to identify the best locations for drilling. In 2018, we conducted a set of geophysical works at one of our sites, and we turned around our attitude towards the results of bringing, and there were big changes in configuration of upstream and its amplitude. Exploration drilling confirmed the convergence of 3D simulation and real situation. We apply state-of-the-art methods of seismic geological prospecting to have high resolution and imaging of the Earth sequence. We designed the works which in future will enable us to map horizons in low thickness formations and do the ground-based seismic exploration as well. Another important criterion for geological surveys, especially in the sites located in aquifers, it's the studying of the tightness of clay top above the site of storage. And we can say that we possess unique practice of studying the tightness of caps and cupolas. We drill no less than 2 wells, and then we test the horizons going upwards using the upwards method, and in the excited well, then we create different regimes of influencing the top side and other sides of the well, injecting the nitrogen and studying the reaction in controlled well. We broadly use this methodology. We have got very positive outcomes when on the results of the studies we reconfirm the tightness of the cap, and some negative one when there was the reaction and control well on the site was considered unproductive. According to classification schemes, tops can have low shielding effect. We study the tightness of caps over formations for UGS, which is a very important information for those would-be UGS. Oil and gas sector approach such a stage of development development when it's not enough to have conventional geological prospecting works. It's necessary to have detailed, proper analysis and map all the information. So we use new research analytical methods. As the project receives more and more information, geological models and simulations are becoming more detailed and more precise so that we could study more those sites in future and cutting costs as well. It's necessary to comply with the established stages of geological exploration works and having mixed methods and having stage geological assessment of the results of work. Despite the systematization of the accumulated material, our company is enhancing the quality of studies, and we also downsize the cost of the project. It's very important for us to curtail the tenor of studying, which is about 10 years, cutting costs of the project implementation. That refers to well drilling, which is most capital intensive. The enhanced efficiency of drilling works is going around the drilling of the wells of dual and triple use as well when we study rock structures, when we do the surveys of the stocks of water to dilute the caverns and to find aquifers and horizons whereby it will be possible to retain brines. Also will streamline exploration methods to mitigate uncertainties and to have high safety and being environmentally friendly. Caring attitude towards nature is absolutely necessary now. We can use more lightweight hardware using wireless systems. So at the end of the day, we can reduce the volumes of fellings and cuttings in forest and take good care of nature. We do the monitoring of the environment and we do the recuperation work since the reversal beginning. More than 65 years had passed on, and the system of UGS in Russia is part and parcel of the system of gas supply of the country. Development of the system of underground gas storage is going on even now. At the plenary session of the 8th Eastern Forum, it was mentioned that the Far East valorizing is the stronghold of future success. So it's a very strategically important task for us to do those explorations. Thank you very much. Very interesting presentation for our colleagues from China, I think. So, geological unit of China also provided us with lots of information. Mr. Burlutsky, assessment of influence of direct current, the system of electrochemical protection. Yes, do be brief, please. Colleagues, I will be slightly digressing from the main subject matter of the conference. Nonetheless, having said that, I think it will come in handy for operation of linear part of the operation of pipelines and also for construction of the UGS. Operation of underground metal pipelines is fraught with risks of accidents due to corrosion. So in accordance with regulation, there is a comprehensive protection from corrosion, which consists of application of protective insulation coatings and active protection polarization using electrochemical protection means. The coatings are destroyed and corrosion is growing, so we need more current in the stations. In all their gas pipelines, the currents of protection could be dozens amperes. In some places, cases up to 100 amps. Studies show that high densities of cathode current could influence strongly the properties of pipelines and clay grounds. They increase the electrolysis and reduce specific electric resistance of the grounds and change other properties of the grounds as well. So the purpose of our study is the assessment of influence of cathodes polarization for the changing properties of clay grounds, which are the space around the underground cathode protected pipelines. We did the simulation and we also did the sampling and laboratory analysis of the grounds and the locations of damage of protective coatings in the trunk pipelines. And then we did comprehensive analysis of the results. The direct current of cathode protection in dispersed grounds enhances the two main electrokinetical processes. It's electroosmotic movement of water and electrophoresis. As the result of that, the grounds around the cathode protecting facilities undergo changes, their structure and properties are changed. In order to do the assessment of change of properties of clay grounds, we did the physical simulation using Cambrian clay sampled from Leningrad region. In this slide, you can see the appearance of this unit for physical simulation. It's schematic. The time of the experiment was 44 days. In the process of the experiment, we exercised electrometrical monitoring to assess the changes of specific electrical resistance of clay under the influence of direct current. In this slide, you can see the schematic of the location of the profile of these microwaves, the apparent resistance of the source ground prior to polarization. The analysis of results of electrometrical monitoring showed the reduction of specific electrical resistance of the grounds over 40 days by more than 1.5-fold. That way, the ground became more corrosion aggressive towards its initial state. Then we did a number of other studies. We studied the changes of granulometric composition. It was the reduction of clay component and the increase of sand and spar fraction, which is due to electrical regulation of the grounds. And by the same token, we identified other changes of properties, like the reduction of the density of grounds, increased humidity content, increased porosity and mechanical characteristics. The internal friction angle grew twofold, for example. Apart from that, in electroconverged ground, the portlandite mineral was identified. Portlandite for portlandite pH should be more than 13. At the moment of the experiment, pH of ground electrolyte reached these high values. And by stock taking of the simulation, I am here to say that the grounds acquired higher corrosion aggression with the reduction of specific electrical resistance. And secondly, the ground has become more porous, porosity grew, and granulometric composition shifted towards grain sand fracture. That means that permeability increased and oxygen amounts also increased. That's corrosion hazard. Then we did field field studies on trunk pipelines in the Ingrid region. On 3 sites, the grounds were sampled and selected at the wall of the pipeline and on the other side of the borehole of the bottom hole at distance of 2 meters. Analysis of granulometric composition shows that grounds near the gas pipeline have got low clay content and higher sand and spar content and PM content as well. And dusty content, and the grounds have got higher humidity, less density, higher pH of ground electrolysis, and higher porosity. This, by the same token, confirms the results of the simulation conducted. We also analyzed, on the basis of 4 parameters, the change of clay content, porosity, humidity, on different sites, and clay content in different sites. You can see it in the slide now. As you see, the site number 2 takes the lead. The highest changes happened right there. And also at site 2, we indicate the highest level of protective potential, maximum level. That way we can come to a conclusion that the level of protective potential greatly influences the degree of electrical conversion and transformation of the grounds.
Conclusion. Cathodic protection, active cathodic protection, is a must. It suppresses the electrokinetic processes of corrosion, and without the cathodic protection, the underground facilities would not exist long. But at the same time, it initiates electrokinetic processes that change the properties of clay soils. And the changes affect such things as resistance, porosity, grain size, and it affects the corrosion aggressiveness of these soils. The corrosion is noted at the high level of protective corrosion, so the overprotection should not be used because it affects the corrosion environment. Thank you. I'm ready to take the questions, if any. Thank you. I would like to make an announcement. So we have listened to many presentations. Some of the participants left early because the buses are leaving. And yesterday I tried to attend 3 sessions at the same time. All of them were interesting. And first I went to one, then I hoped to get next door. But no, it never happened, and I left late, and it was too late to go to another session. So we will collect all the presentations. In fact, the presentations are already, we have them already, and we will have them published, and it will be very useful for you, and then we will disseminate it, and all the presentations are in 3 languages, and we will think on how to send it to you by email. And thank you for your stamina and perseverance. Thank you. Ну вот вообще, я и начинал, и заканчивал.
Ты безобразие.